Yes, it is.
Hello, everyone. This is Michael Gibbs. So great to have you back. For those of you that don't know me, I'm the founder and CEO of Go Cloud Architects, and we're an organization dedicated towards building high-performance cloud computing and networking careers. Today is day 3 of our completely free AWS Certified Solution Architect Associate 2022 training program. We will be doing AWS Solution Architect Certification Training, and again, this is a free AWS full course. To let you know how we're going to run the course is as follows. We'll have approximately 40 minutes of training and 20 minutes of question and answer sessions every hour. So we're going to try and make this as much of a classroom-like experience as possible. What'll happen is we're going to present, questions will come in, and we'll periodically stop to answer the questions. You know, when you're doing your AWS Certified Solution Architect Associate training, we want to make sure that it's not just, here, watch this video, and you're on your own. Because then you won't know what you know, or you won't know what you won't know. So we're going to make this live, we're going to make this fun, we're going to make this interactive. This is going to be like a real AWS bootcamp, as if you bought it from one of the global training providers, as if you took it from AWS directly. So real excited to have you back here today. This is something that we truly, truly, truly love doing around here. We love providing free AWS training, whether you're building a cloud architect career or a solution architect career or a cloud solution architect career. We want to help you. Now, we're going to get deep into some of the tech as much as we can in certain places. There'll be a point where we're going to have my good friend and fantastic cloud architect friend, Alonzo Coleman, and he's going to be maybe doing some labs to try and get you guys a little hands-on. I will give you the architectural approach. I will explain how the technology works, what it is, why we use it, and those sort of things. And I'll try and give you as much as we can in a short certification training program to give you the business acumen and the cloud architect knowledge, so you'll be prepared for a cloud architect job. So we're live. Now, of course, anytime when you do things live, computers can fail, internet connections can fail. Literally speaking, anything that could go wrong probably will go wrong. So we're going to make it as fun as possible. You know, you build a plan, you build a backup plan, you build a backup plan, and when everything fails, all else fails, adapt, improvise, overcome. And for those of you out there that know what I mean, you know how important it is to be adaptable, be flexible to the situation as a cloud architect, as well as everyone. So if you're here and you are ready to go, type hashtag cloud hired. And I know everybody's here. And you know what? Hit that like button if you don't mind. It's good for the algorithm. It helps more people see our free content. So if you can hit that like button, great. If you like what we've been doing for the previous 3 days. If you've not seen what we've done for 3 days, wait until you experience it before you hit the like button. But if you've been here and you've been participating and you've been having a great time, if you can help us with that algorithm by liking, commenting, subscribing, and sharing this with others. Our goal when we do free AWS full courses and free AWS Certified Solution Architect Associate training is to really give people the kind of training that they couldn't afford. A good training program like this is about $4,000 or $5,000 where they're live and interactive, and we know that's outside the budget of many people throughout the world. We want to make sure that you get access to this kind of training anyway, and that's why we're doing it free. Coming real soon, we're going to have a free Cisco Certified Network Associate course. The reason we're going to do that is the cloud is a network and a data center that's virtualized. And you know who knows the network and the data center? Network engineers. So we're going to have some free networking training coming your way as well. Just to remind everyone that tomorrow, IT Excel, the executive IT recruiting firm, is coming in again. They will bring in either their CEO or one of their executive officers. They will talk about cloud architect jobs. You'll be able to send in your resume. You'll be able to ask them questions about what employers want. I got to tell you, these are really good recruiters. They've helped more students of mine get jobs in the past 20 years than I can even count. They've helped more people than I know get hired. They have 20 full-time recruiters in New York City. They are connected with thousands and thousands and thousands of hiring managers spread across the country. They've got connections all across the world. And you know what? They're coming tomorrow, free at 10 a.m. So IT Excel is coming tomorrow. So before the end of this, We will give you guys the link to do that because we want to give you everything we can to help build your cloud architect career. With that in mind, we're going to go back to some training. We had some fun training yesterday, and yesterday we were working on databases. So as a refresher, we talked about relational databases. We talked about, what's the word I'm looking for? We talked about NoSQL databases. We talked about data warehouses. We talked a little bit about scaling the databases. We talked about read replicas. We talked about caching, and we talked about queuing. So, those are the kind of things that we discussed yesterday. So today what we're going to talk about is a little bit more on the databases, and then we'll get into some really cool, really fun topics. So I promise today we'll get into some good technical content. And if you guys are ready, we're ready to get started. Just bear with me for a minute to figure out exactly where we left off so we can give you guys the best experience ever. So just bear with me. Let's talk a little bit about extraction, translation, and loading. So yesterday, we talked a little bit about the creation of a data lake, where we talked about taking data from relational databases, NoSQL databases, data warehouses, object storage, and we talked about really using these kinds of environments to aggregate your data so that you can run business intelligence tools and make better business decisions. So let's look at the world of data. Lots of data coming in from all angles. This data can do some incredible things to help us. This data can help us make better business decisions. This data can help us, look at the data to make better predictions. Data is our friend. But I want you to think about data. Imagine you've got data coming in from 1,000,001 sources, and they're all in its own format. Now, let's think about this. Data coming from here in a relational database stored in columns and rows. Data in a NoSQL database stored, however, with a flexible schema. Now you've got data in a data warehouse. Now you've got your data sitting in object storage. Lots of data. So what do you do with it? How do you take the data from one place and another place and another place and get it all somewhere smooth so you can analyze the information? You use something called an extraction, translation, and loading tool. And let's be fair, there are a lot of these tools, lots of custom work. Now, one of the great things is when you go to a cloud provider, one of the reasons the cloud provider is so cool is as follows. The cloud provider has been doing this business for a long time. So normally speaking, in an enterprise, you'd have to buy an expensive tool or custom build a tool. And a lot of the work with extraction, translation, and loading, meaning taking data from one database and another database and all these other data sources, a lot of that information takes time and manual coding. But when you're dealing with AWS, they've got a tool that's been pre-made. And the tool they have, their extraction and translation and loading tool to aggregate your data from different sources, is called AWS Glue. So what is AWS Glue? It is an Amazon branded, Amazon designed, Amazon coded extraction, translation, and loading tool. So it will take the data from the various databases and load them into the appropriate place. Remember, every database has its strengths and weaknesses. NoSQL databases scale incredibly. Relational databases give us the relationships between variables. Object storage lets us dump a whole lot of stuff into an environment and have metadata. So when you combine these, that's really where the magic happens. You're aggregating, and then you're going to be able to make better decisions. So it's all about the data aggregation. So that's realistically speaking what we're talking about. Now, when you have a tool that can do this for you, it's pretty terrific. So normally speaking, what would happen is you build your own tool, you put your own tool on a virtual machine, and what would happen is the tool in the virtual machines will catalog your data, make it searchable, queryable, that kind of thing, and can be then loaded into a database, data warehouse, or really speaking, anything that you desire. That's what you do with ETL tools. But with AWS, it's easy. They have a pre-made tool, pre-coded tool called Amazon Glue. And Amazon Glue is already running in a serverless environment. Now, I may not be the biggest fan of serverless. And the reason I'm not is I like to be able to go on and off cloud providers' data centers very easily. But this is a really nice tool. It starts serverless. There's nothing that needs to be built. You just you take the glue tool, and inside of the glue tool, you point it to your data, and AWS Glue will basically discover the data, store it in a catalog, and it'll create a catalog of metadata or data about the data. So then once you've got this catalog, Amazon Glue can literally put it wherever you need. So this is a really simple and a nice, elegant solution when we're really trying to talk about some of these things. So let's look at this architecturally, what it looks like, because this is a really nice, elegant tool. Basically, you've got over here, you've got S3, which is your object storage. You've got glue crawlers, and the crawlers are going to go be pulling information from Athena, which is for example, a relational database, Redshift, which is a data warehouse. You'll be using Elastic MapReduce which is going to do similar ETL type functions, mapping and reduction from one database to another database. And then you're going to use a tool like Tabulo or QuickSight to visualize the data. See, the whole point of these data lakes is to do something with the data. That data is your friend. The more information you have, the better decisions you can possibly make. So data is really great. So that's realistically what we're talking about. Oops, didn't mean to do this. So now, we've talked about relational databases. We've talked about data warehouses, talked about NoSQL databases. We've discussed databases, but let's talk about high availability database design. Now, database design is very different for high availability than high performance. So let's talk about this. Yesterday, we talked about increasing performance, and we added read replicas to offload read load from the primary database. Yesterday, we added caching to reduce the load on the read replicas, which is further reducing the load on the master database. Yesterday, we talked about adding queuing to make sure that messages didn't get dropped on the way to the master database. All good, right? None of that had anything to do with high availability. It all had to do with increasing performance. So now let's talk about how do we build for high availability. Well, it all goes back to this military adage. 1 is none, 2 is 1, and 3 is greater than 2. For the people that are asking the question, from Emmanuel who's asking the question, the video will be here later. Go back and watch it. Absolutely. So it all comes down to that same adage. No single points of failure anywhere. So how do you design a database to really grow, to really scale with regards to high availability? You do it in the following way. You host the database in multiple availability zones. So 2 data centers, that's it. So reminder, on the first day, we talked extensively about what is a relational what is an availability zone, which is a data center, what is a region, which is a large geographic area. We talked about local zones, edge computing, and we talked about edge locations, which was related to CloudFront. So what do you do with AWS for high availability database design? Use multiple data centers, minimum. So if you're going to host your database at all in AWS, you should probably host it in 2 data centers, which means 2 availability zones. Why you should do this is you have your database in a data center and you copy it to another data center. Now, if the data center were to have a flood, a fire, an earthquake, or a massive cable cut, it doesn't matter. Your systems are available in another data center. So if you want to increase availability, you use multi-availability zone. If you want to increase performance, use read replicas. I'm going to say this again. It's a text question and it is confused by almost everyone. Multi-availability zone does not improve performance and improves availability. Read replicas, caching, and queuing improve database performance. Please know that. You will probably see it on a test, but more importantly, you need to know this for your career. Much more important than just passing an exam. So here's what multi-AZ does. You've got your database saying US East. It will synchronously copy all of your data to the backup database saying US West. This backup database will do nothing unless there's a failure or a situation that will cause a failover. But it will do nothing. And we'll tell you what will cause it to fail over, but it'll just sit there and be backup. And then if you need it, it'll kick on. It'll do everything that needs to be. And when you bring up your new database, it'll synchronize the old data back to the old database, and you will lose nothing. High availability database design, put your database in a minimum of 2 availability zones. Now you've got your database in 2 availability zones. What's it going to look like? I'm going to show you what it's going to look like right now. Identical copies in 2 places. Look at this architectural diagram here. We've got a 3-tier web app, a web, an app, and a database tier in 2 availability zones. So should anything happen in availability zone A, guess what? Availability zone B will take over, and everything is good. So now you know how that works. Now, what will cause this availability zone to switch over to this availability zone? Let's talk about that for a moment. Here is what will cause an availability zone to fail over. If the primary database fails, switch to the backup. Makes sense. If the availability zone were to go away, like due to an outage, switch over to the backup. The database services changed, switch to the backup. You do maintenance on the database, like patch and the operating system, guess what? Fail over to the backup. You initiate a manual failover, something like a reboot, but fail over to the other system, it will fail over. So now you know the concept of high availability database design. It is about making sure you have sufficient information, sufficient information from one data center to go to another data center should anything happen. Okay, now we're going to get into some basic networking, which is my favorite area. But prior to getting into some basic networking, I want to make sure that you're ready and you don't have any last questions on the databases. So if you guys have any more questions on the database, like high availability database design, let me know. If you do not, I will go straight to the next section, which was an intro to networking. But I need to make sure that I know where your questions are before I move on to the next thing. Can you host your data in 2 separate provider data centers? The answer is yes. You definitely could and should. So if you're dealing with multi-AZ, you're dealing with these situations. 2 separate data centers. Now, if you're talking about 2 cloud providers across 2 data centers, of course you can do that as well. Now, you're going to probably be using your own manual database, like you'd set up an EC2 instance in one environment, and you'd install your database software, and you could do that in AWS, you can do it in Azure, and you can do it in GCP the entire time. So yes, absolutely. What about scalability of the database? So Babita, we spent a massive amount of time talking about scalability yesterday, and you can definitely watch the replay. We talked about scaling relational databases, and we talked about adding read replicas to offload the read traffic off of the master database. We talked about adding caching to reduce the load on the read replicas, as well as the master database. Yesterday, we talked a lot about adding queuing to reduce the write load on the master database. We talked about, with no SQL databases, partitioning the databases. We did not discuss partitioning of relational databases, because that's not without its gotchas, and not even some of the database providers don't do that with relational databases, but they almost always do it with no SQL databases. So if you want to go back and watch yesterday, there's a lot of content on that, and would love you to see it, please. What is the technology? So Jamal, that's a great question. There are a lot of different technologies that you can use for failover. In these cases, most of the databases themselves have their own heartbeats and their own signalings and clustering mechanisms. So realistically speaking, that's typically the way that it works. Killian, if you fail over to a backup AZ, you have to clone the backup AZ right away for availability. No, you don't really have to do anything if you fail over to a backup AZ if you set it up properly. What is the difference between scalability and availability? Les, that is a great question. Scalability is as follows. Can you deal with 100 users, 1,000 users, 1,000,000 users, 1,000,000,000 users? That's scalability. High availability means that it's going to be there when you need it. So for example, a high availability network will be available 99.999% of the time, which means the network will be up with the exception of 5 minutes and 15 seconds of downtime per year. A 4 nines available network is basically 99.99% available, which is what you can get on AWS with 2 availability zones. With regards to that, that will give you 4 nines availability, or about an hour's worth of downtime per year. So realistically speaking, that's kind of where you're going from. Can you store session information in DynamoDB using DAX? Well, you could, but remember, you're not looking for accelerators and in-memory caches to store your information, because all that information goes away with reboot. You're trying to store it in the actual data center itself. Those kind of things are designed to accelerate the database as a rule. Availability zones are data centers. That's exactly correct. The cloud providers should really say, hey, the regions of geography and availability zones a data center. But the cloud providers really like their mysticism. When you don't know what it is, it sounds really cool. It sounds technical, a lot like some advancement and innovation. The reality is an availability zone is just a data center. Oracle's got their own tools for replication of auto things. What about or a cluster versus I don't know what you mean by what about that. So I don't even know where to begin to answer that. I'm not trying to be difficult. Is high availability database disaster? So no. High availability database design is keeping your databases available when needed. Disaster recovery is preparing for massive things: earthquakes, nuclear attacks, floods, all kinds of disasters along the way. Disaster recovery could be included in training and building for availability, but it could be separated. So realistically speaking, the high availability database design we're talking about is not related to disaster recovery, but disaster recovery is part of an overall high availability enterprise-wide strategy. Mario Millen, how do failovers work? There are a lot of failovers, Mario. So I want you to think about anything. Whenever you're dealing with failovers, think about a heartbeat. So whether it's a routing protocol like OSPF that says, hello, 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 or to identify its neighbors, whether it's a heartbeat between 2 databases where they're saying, are you there? Are you there? Are you there? Whether it's a health check from a load balancer saying, are you there? And the server responding, yes, I'm here. Are you there? Yes, I'm here. It's all going to be the same thing. So whether it's VRRP or HSRP for making a virtual router, whether it's a routing protocol with an OSPF hello, whether it's a heartbeat between these systems, whether it's a health check with regards to DNS or load balancers, they all use the same kind of thing. They send a periodic message, are you there? Are you there? And they get a response, I'm here, leave me alone. You get another question, are you there? And they say, I'm here, leave me alone. And you get another message, are you there? And they say, I'm here, leave me alone. So all of these failovers work with that. And what happens is typically, whether it's a hold time, are you there? Are you there? Are you there? No response, switch over. And that's typically how all these failovers are performed. Yogesh, in the case of a failure, what happens to the transaction as they're supposed to be ACID? Well, if the thing is written to the database, it will immediately be synchronously copied to the other one. So if the transaction is in the process of being written and maybe something gets rebooted, you may lose that transaction, but only if it didn't occur. Once it occurred, they're ACID and they should be pretty stable. Arun, can you get a 2-tier architecture and a 3-tier architecture and also have cost-saving concept? Look, you can put all this, Arun, on a single server. The Linux, Apache, MySQL, PHP stack is a single server architecture for web apps. And it's totally appropriate. The problem is, well, how big of a server can you have? 128 cores? 4 terabytes of DRAM? At some point, that's just not enough. At some point, you need 1,000 128 core servers with 4 terabytes of DRAM for your website. So you can do 2 tiers, you can do 3 tiers, but it's really based upon what you need to do. Now, I'm going to recommend that whenever you do 3 tiers and you decouple things, boy, they scale better. If you set it up to scale better, you won't be troubleshooting things later that don't need to be troubleshooted, and you will be in in a much better position. So generally speaking, try to decouple. Nilesh, what is the main difference between scalability and elasticity? Both look the same to me. Nilesh, there is no such thing as elasticity. Elasticity is a made-up word from Amazon. It's a fake word. It's a marketing term. It is meaningless. What the point of elasticity is it'll grow and scale and do what it's supposed to do. That is a marketing term. Scalability means that it will scale, meaning if you need to grow to 100 users, 1,000 users, 1 million users, that's called scalability. If you meet with the chief information officer of a Fortune 100 company, if you meet with a bank, if you meet with the CEO of Cisco, the CEO of Microsoft, they know what scalability is, and they've been building and designing for scalability forever. If I were to go meet with the CEO of Microsoft and I'm going to make your systems elastic, they would laugh me out the door. They would say, we are not Amazon. We don't use funny marketing terms. We use scalability. If I would try to pitch that to executives at Google, they would still laugh at me. So I'm not trying to laugh at you. I'm saying Amazon and their marketing team have worked so hard to give us such crazy terms for things like simple storage. I mean, seriously, tell me it's object storage. Elastic everything? I don't need to know elastic everything. A cache isn't elastic. It's just the AWS brand, stick elastic in front of everything. Google puts cloud in front of a lot of things. And you know what? From a marketing perspective, from a business perspective, it's very intelligent because it enables the cloud provider to really differentiate themselves. When they make it clear that when they come up with something really cool, simple storage solution or whatever they want to call it, that's great. Guess what? Amazon Simple Storage. It makes it harder for you to conceptualize. If you don't know that it's object storage and it sounds fun and it sounds fancy, the price goes up. And if you're dealing with it this way and it gets more complicated, people don't know what it is. So when you charge a certain price, it's like, wow, I'm getting great storage. Now, if you're an architect, you need to know what it really is. So I don't like marketing terms. I don't tell people that I've got an elastic business. I just tell people how to make their systems work to go from one person to a billion people. And by doing that, I help them. So great point, great question. Stay generic, stay out of the marketing branding, and your career will grow much faster. I think I'm being informed by my team that we have to get back to the content. So if you're enjoying your site, type #CloudHire because I need to know you're awake, alert, and oriented for the next part because the next part's in networking where it's going to, what is an ACID transaction? An ACID transaction basically means you take your system, you write to the database. It's either all or nothing, meaning you wrote to the database, you didn't write to the database. One transaction doesn't affect another transaction. An ACID database means that if I write, instantly after a write, everybody else can get the new content. So that's what's meant by an ACID database. Immediately consistent, all or nothing. One transaction doesn't impact another. Okay, I'm starting to see things. Now we're going to get into a little bit of tech here. I've been asked by my team to remind you, if you're enjoying our free AWS Certified Solution Architect Associate 2022 program, please leave a like. It helps with all the algorithms. So now we're going to do a basic networking review. The cloud is nothing more than a virtualized network and a virtualized data center. And because of this, networking is just so critical. I mean, networking is so critical that if you don't have the network up and running perfectly, I'm going to tell you, nothing works. Nothing works. So let's do some basic networking. And then we're going to get into the VPC section. Of course, in the VPC or virtual private cloud section, what we're going to do is as follows. We're going to do this. We're going to make sure you have a lab and you can create a VPC, and Alonzo will work with you on that, and it'll be really fun. So let's go back to the networking. The first thing I want to talk about is the OSI model. Why? The OSI model is used by every network professional in the entire world. The reason we all use the OSI model or the Open Systems Interconnect model is it enables us as network architects to really be able to look at what's going on. And we troubleshoot based upon the layers of this model. So this is something that's really important to us. We've got a 7-layer model. Now, networking consists of only 4 layers. The entire stack consists of 7 layers. Let's start with the basis, the physical wire, the physical cabling. This is layer 1. Layer 1 is a wire. So at layer 1, we've got a wire or a fiber optic connection. It's physical. It's the cabling. That's layer 1 of the OSI model. It's the Ethernet cable. So here at layer 1, it's a physical thing. We're sending electrons on a wire or photons on a piece of fiber optic. And with that, we're transmitting bits of data. So physical layer, layer 1, physical wiring or cabling, layer 1 of the OSI model. This is where your tier 1 troubleshooting is. Is it plugged in? Now, the next layer of the OSI model is as follows. The data link layer. The data link layer is the hardware layer of networking model. If you've got a computer and it's got a network card in it, it's got a hard-coded address on that network card. A hard-coded address. That is called a MAC address. At layer 2, you've got a MAC address. If you want to look on your computer and you want to look at your computer's address, I think we can see it. Hold on, CMD. Sure, I haven't used a Windows computer in a long time, but I had to switch over to one because my Mac didn't work. If you take, for the kind of work that we were doing, if you take your computer and if you're on a Linux system, you open up a terminal and you type ifconfig. If you're on a Windows computer and you do an ipconfig/all, you'll see your Ethernet adapters. And on your Ethernet adapters, you're going to see a physical address. The physical address on one of my cards is F as in Foxtrot, C as in Charlie, 3497 Alpha 0 Foxtrot Delta 16. That's my card's physical address. And you know what? The first part of that physical address, the first 6 bits, that FC 3497, that is something called the OUI, which identifies the company that made the Ethernet card in my system, which is Intel, and that's Intel's OUI. So layer 1 is cabling bits and bytes. Layer 2 is a hardware address, a physical address like your MAC address. At layer 2, we're sending data that's called frames. So bits at layer 1, frames at layer 2. That first cloud that I worked on in 1998 that was called Frame Relay. Why was it called Frame Relay? Because at layer 2, we were pushing frames. It was a layer 2 transport technology. Next, what do we have on layer 3? We have layer 3. Layer 3 is the logical addressing we're going to use. It's your IP address. We manually configure it. Here's what exists at layer 3. Your IP addresses. Here's what else exists at layer 3. Your routing information. So layer 3 is your routing. Layer 3 is your address. An IP address is a logical address that you put on there. That is what we're talking about when we're talking about routing. Logical IP addresses. So realistically speaking, this is what we're actually talking about. So let's move up. Let's start. Layer 4. Layer 4 is transport. Layer 4 manages the sessions. So let's look at it this way. Layer 4 is TCP and UDP. So let's look at the 4 layers, because in networking, there's only 4 layers. Layer 1, physical layer. Layer 2, data link layer. Layer 3, network layer. Layer 4, transport layer. For networking people like me, that's it. We go no further. Now, let's make sure you know the next 3 layers. Layer 6 is the session. This basically controls the connection that exists beneath it. Layer 6 is something called the presentation layer. Again, something we networking people don't even think about. But the presentation layer basically presents the networking information to the application layer, and the presentation layer handles encryption. So we still talk about it sometimes. And then we've got layer 7, which is the application layer. This is the stuff we use. We go to a website, it's layer 7. I do a secure FTP, it's layer 7. I send an email, it's layer 7. I open up a web browser, it's layer 7. It's an application. So let's walk through it one more time because it's important. Layer 1, wire, physical layer. Layer 2, data link. Think Ethernet, think frame, think MAC address. Layer 3, think network, think IP address, think routing going on. And you think about packets that you're sending on the wire. Layer 4, transport. Think of transport as TCP, UDP, and we send segments. Layer 5 is session. It controls the connection. We're dealing with sockets. Layer 6 is the presentation layer. It's really presenting data and handling encryption, like TLS, for example. Layer 7, application users. This is where you connect to. These are things that you use. Those are the 7 layers. So now what we're going to do is as follows. We're going to do a very brief IP addressing thing and a very brief subnetting, supernetting, route summarization thing. And then after we do that, and it's going to be very brief, we're going to go into the VPC. Now, when we go over this basic subnetting, we may not have as much time as we need to. So here's realistically speaking what we're actually talking about. When we go through some of these kinds of things in networking, we actually created a 4-hour complete subnetting workshop. Chris or one of the people from my teams will do the following. They'll provide a link in the chat window to the free subnetting workshop we did. And if you guys want me to do another free subnetting workshop, I am happy to do it. If you want me to do subnetting, type subnetting workshop in the chat box, and I'll find time to do another 4-hour subnetting workshop someday soon. But in the meantime, we're going to go through a great thing. But if you want or need a bigger subnetting thing, type subnetting, and we will do something. And also, well, if you're enjoying the content, if you can hit the like button, share with others as well. It's always good for our things. Here's the current subnetting workshop. If you want us to do it, we'll do us. Let them know. Run subnetting workshop, and I will have Chris from my team add it to the list of things that we'll do, because we want to do anything we can to help you in your cloud computing careers. So let's talk about IP addressing. Let's first begin with what is an IP address. Quite simply, an IP address is a logical address or an address that you put on a computer. Every device that needs to talk to another device must have an IP address, kind of like your house. Your house has to have an address. If you don't have an IP address, you're not going to be able to get there. So if you can't have an address, you can't get there. So what needs to occur? Every device needs to have its own IP address. And for devices to communicate with each other, they need to have unique addresses. For example, if I made a photocopy of myself, and neither was Mike, and my next photocopy is Mike B, how would you know who's Mike and who's Mike B? You wouldn't. Now, if you named one photo Mike and the next photo Mike B, and you were going to say send data from Mike A to Mike B, you could do it. But if all you knew was Mike, and both photos had the same names, and they were identical photos, and I was identically dressed, how would I send information to each other if we had the same name? The answer is we couldn't. So with your house, for you to get mail delivered, you have an address. If you had the same address as your neighbor, the mail person wouldn't know whose house to give it to. Well, the network is the same way. For the network to work, realistically speaking, for the network to work, everybody has to have a unique IP address. So that's what we're talking about. So every device, every entity needs its own unique address. For the internet to work, I'm going to say this again. Every device needs to have a unique IP address. Okay, so here's where the problem comes from. When we're dealing with IP version 4, which is still the predominant IP addressing scheme we're using, we have a 32-bit address. So if you want to know the number of addresses that are available to us, you can do 2 to the 32nd power. And you'll see it's a pretty large number of addresses, but not enough. See, here's what happened. When the internet was found, and when I started working on the internet, um, when I started working on the internet, here's what happened. There weren't that many things on the internet. It was never an issue. We didn't have a problem because, we had 2 to the 32nd. Now, by comparison, here's the thing that's going on. Every phone has an IP address. Every house has an IP address on their TV, on their computers, on their printers. Literally everything. That's kind of what's going on where you need these IP addresses. You need an address on everything. Your refrigerator, if it's a smart refrigerator, has an IP address. The cameras in your house all have IP addresses if they're. We just ran out of IP addresses a long time ago. And because we ran out of IP addresses a long time ago, we have to do something. We came up with private IP addresses. So here's the thing about private IP addresses. The Internet Engineering Task Force decided to specify, we all got together, because I've done a lot of Internet Engineering Task Force kind of work as well. And what happens is when you're here, you get together with a large group of people, you write what's called a request for comment, and basically you create a specification. Now, the Internet Engineering Task Force did as follows. They created a specification for private IP addresses, which included the 10./8 address space, 10.0.0.0/8, the 172.16.0.0/8. I don't know why that says 0/1 /8. And it also includes the 172.16.0.0/12, and it includes the 192.168.0.0/16. So here's the thing. Every organization, or nearly every one of them, is basically using the same addresses. So anytime you're going to address your VPC in AWS, VPC in Google, VPC equivalent in Azure, your chances are for your internal stuff, you're all going to be using these private IP addresses from RFC 1918, meaning the 10/8 address space, the 172.16/12 address space, and the 192.168.0.0 address space. Now, let's walk you through some legacy things, because on these exams, you're going to hear the term CIDR, or classless interdomain routing. And here's where this is coming from. A long time ago, we had this concept of classful addresses, and classful addresses use the same mask. So a class A address was anything from 1.0.0.0 all the way to 126.255.255.255.255. And what would happen is we would have a /8, which would give us 2 to the 24 hosts available in a subnet, but only one. Now, the next thing, and we'll talk about really where it came from, were the Class Bs. And Class Bs were effectively a /16. They began from 128 all the way to the 191.255.255.255.255. And then after that, we had this concept of a Class C address. And with the Class C address, we had a 192.168, or basically we had the 192.0.0.0, and it went all the way to 223.255.255.255.0. We had the Class D addresses, which we used for IP multicast. I won't go to them. And we had the Class E addresses, which were experimental. Here's the thing. They all had classful boundaries, meaning a 1.0.0 was S/8, which is great if we were going to put 16,777,000 hosts in a single subnet. But here's the problem. By doing this, by putting all of our hosts in a single subnet, we would have so many broadcasts that we couldn't do it anyway. So we can't put more than about 500 hosts in a subnet, and realistically speaking, not even more than 250. So we couldn't use these Class A addresses, because remember, every interface on a router, every network card on a server needs to be on a different subnet. So if we stuck with these old Class A addresses, and we had 3 Ethernet cards on our computer, we would have 3 Class A addresses, and each Class A address would burn 16,177,000 addresses. So literally speaking, for 3 users, we would use 48 million addresses. Now that is obviously not appropriate. So we came up with the concept of a classless address. Here's a classless address. A classless address is something that, for example, does not adhere to a classful boundary. So when you create a subnet mask that's not the default, it's considered classless. That's it. That's all classless interdomain routing is not holding and not saying that you have to use the classful boundaries. And that's realistically it. So how do we go from classful to classless? The answer is we subnet it out. And that's it. And like I said, we'll do a quick walkthrough now. And if you guys need, we'll do that subnetting workshop. I had asked some people to do some subnetting workshop. If they wanted it, it looked like a lot of people commented subnetting workshop. So we will do a 4-hour subnetting workshop coming very, very, very soon because it's an important concept to know. So let's now look at what is subnetting. So let's begin by this. Let's take this simple environment. Let's say I've got one class C address, a 192.168.1.0/24. Let's say that I know that I need to put 6 servers in 3 different subnets, but I need multiple subnets. What do? I can take my class C network and I can chop it up into middle networks, and each one will be able to communicate with each other and nobody else without going through a router. So say I take this 192.168.1.0/24 and I break it into a 192.168.1.0/28, a 192.168.1.16/28, a 192.168.1.32/28, a 192.168.1.48/28, a 192.168.1.64/28. This is what we need to do. Now, I got to tell you, 90% of all problems with technology are because someone did not have the skill to design the best IP addressing scheme. If the IP addressing scheme is not set up properly, what happens is the routing is wrong. And if the routing is wrong, what's going on is nothing will work properly. So almost every problem I've ever seen in tech is when someone that was not a network architect, someone that was more of a jack of all trades, designed the IP addressing scheme. The IP addressing scheme is wrong, and the rest of your design and architecture will always be wrong. Nothing will work well if your addressing scheme is wrong. So let's walk through this a little more with a little chart, and I'll do a complete class if anybody needs. So it looks like lots of people are looking for subnetting, so I will do it. But I just want to show you basically what happened here. I took the 192.168.1.0 subnet /24, and I subnetted into all of these individual class Cs. So keep that in mind. Now, if we listed an intro to subnetting video, I strongly encourage you all to watch it. It is hours long. We work through lots of project examples. Please see it because you guys are definitely going to need it. And I will make another workshop within the next 4 weeks where we spend 4 hours with you and you teach you guys subnetting because it is so critical for your cloud computing career. So let's talk. So one other thing, if you want to know how many hosts are available to the subnet, you can do 2 to the number of bits that you actually have, and that will give you your answer. So in this case, we borrowed 4 subnetting bits. So if we can do 2 to the 4th, we get 16. So that would be the total addresses. Now, in a normal world, the first IP address is reserved for the network, meaning the 192.168.1.0. The last address of that subnet would be 192.168.1.15. That is used for broadcast. It is not usable. So remember this. When you're dealing with IP subnetting, as a rule, 2 addresses are always lost. Now, when you're on the cloud, it's different. Every cloud provider does their own weird IP addressing things. AWS is very unique in the way they do IP addressing. They reserve the first 4 IP addresses of the subnet, and they also reserve the broadcast. So realize, if you've got a /28, which is the smallest subnet you can use in AWS, and you've lost 5 addresses versus 2 addresses, you only have 11 addresses left over. So if you're taking an AWS Certified Solution Architect Professional exam, or you see it on your AWS Certified Solution Architect Associate exam, Remember this, they burn more addresses. So if you're asked a kind of a question that says, hey, you got a load balancer, you got some web servers, app servers, and some servers, and you've got a /28 and auto scaling stopped, why do you think auto scaling might have stopped? Because you may have these systems that are scaling up. Each system needs a new IP address. If you run out of IP addresses, auto scaling will stop. So no, AWS burns 5 IP addresses. The first 4 are burned, and the last one, the broadcast, is burned. So know that. Now, while we're talking about subnetting, let's go the other way, because this is even more important. Let's talk about supernetting. This is one of the most critical things you will be doing in a cloud computing career, is supernetting. Supernetting is the exact opposite of subnetting. Supernets basically take multiple subnets and combine it into a big one. So, okay, wait. We're going to take our networks, we're going to subnet them down for more efficient use of internet. Now Mike's telling me, let's supernet them and take these little small things and bring them together. Okay, what's really going on? We're going to be using an elegant subnetting scheme to decouple our environment. We're going to segment our traffic with good IP addressing scheme. The more subnets that we create to isolate our environment, which is the best thing we can do by creating additional subnets, the more subnets we create, the more routes we put in the routing table, which is fine to a point. So when you've got millions and millions and millions of routes in the routing table, it takes a lot of CPU performance in these routers, it takes a lot of memory, it takes a lot. And if you don't have big, giant, really awesome, high-powered routers and firewalls, then it could be too much. But that's not really what we're talking about. When we're talking about supernetting or route aggregation, we're talking about doing it for another reason. What we're talking about doing is we're talking about optimizing traffic. So let's look here. You've got these 4 subnets, 192.168.0.0/24, 192.168.1.0/24, 192.168.2.0/24, and a 192.168.3.0/24. These are 4 subnets. These are 4 specific routes that I would be spending to the VPC. And if I sent all these 4 routes, awesome, it's going to work perfectly. But do you know of any routing limitations on the AWS cloud? I told you some yesterday. AWS will let you have 100 routes in your routing table. I'm going to say this again, 100 routes in your routing table. Do you know what 100 routes is? Nothing. Nothing. The kind of systems I work on with have 40,000 routes in the routing table, internal to organizations, and 800,000 routes from 10 different internet service providers. And AWS says you can have 100 routes. Nothing. So those people like me that have been network engineers and architects for 30 years, remember when we worked on routers that had a 20 megahertz CPU with a meg of DRAM. Guess what? When you're dealing with the cloud, you're dealing with those old ancient kind of routers that can only do 100 routes. How did we do it 20, 30 years ago? We got real good at route summarization. How do we deal with the cloud providers that give us 30-year-old routing capability? We use the same route summarization we did 30 years ago on networking. We don't have a choice. We do that with the cloud providers, and then everything is optimal. Why else would we do this? We want to hide some of the information in our current system. Why else would we want to do this? We want to reduce the scalability. We want to traffic engineer. So that's why we use route summarization, to work around the weaknesses of the cloud. In some cases, we kind of do that. I think that's pretty important. But also to reduce the routes that we're sending to our cloud providers. They don't let us sound a lot of routes. The cloud providers aren't stupid. They're smart. They've got great network engineers. They've got fantastic network architects. They've got exceptional people there. You're not the only client. We're not the only client. Everybody that's there does their own kind of thing. So realistically speaking, people do what they need to protect them. AWS, Azure, these people have millions and millions of clients. Imagine taking in 100 routes from 1,000,001 clients. It's unbelievable what they have to deal with. So that's why the cloud providers aren't willing to take too many routes. They can't, because they have too many customers. So summarize accordingly. And that's why route aggregation or supernetting is so widely used. Now, before we get into the VPC, and we'll get into the VPC, let's briefly talk about IPv6 addresses, and they are a newer form of IP address. So an IP address is a 32-bit binary address. So realistically speaking, when you're dealing with this 32-bit binary address, this is via IP version 4, you've got 2 to the 32 in terms of usable hosts, which is a lot, but not enough. Now take IPv6. It is a 120-bit hexadecimal address. So take 16 to the 128th power, and now you know the number of addresses that are available with IPv6. Infinitely more. So their IPv6 addresses are being used by lots of people, but realize right now they're predominantly being used by mobile phones. Now, when you sign up for an EC2 instance on AWS, you will automatically get an IPv6 address. You can disable that if you don't want. So let's do this. Let me answer some questions, and then we'll get into the VPC. We'll talk about the VPC. Alonzo will do a really, really cool and fun lab on the VPC, and I know Alonzo's got a cool one planned for you. Anytime we're dealing with a great cloud architect like Alonzo, I'm always expecting Alonzo Coleman to give you guys something good. So let's do some questions prior to getting back, and then after we get the questions, let's go back to the course. So Chris, I saw one question come about my eye. I'm going to address that right now because it's troubling me. I was involved in a horrible accident approximately 10 years ago. I was unable to walk for 3 years. I lost the use of my left foot. I lost the use of my left hand. I did between 6 and 9 hours of physical therapy every day for 8 years straight. And at the end of this accident, I'm left with a goofy eye twitch. So I'm still here. I'm providing free cloud architect training, free AWS certified solution architect training. I got an eye twitch that was a result of an accident where the doctors told me I would never walk again or even be able to sit into a chair again. So I have an eye twitch that's left over, so I thought I'd address that. So thank all of you that are participating. I really do appreciate you all being here. Now, Chris, who has the next question? Okay, so Yogesh asked a great question. I can finally see it on the screen. What is a VLAN? A VLAN is as follows. If you take a switch, I got one. Take a switch like this. Notice this switch has a whole lot of ports in it. Now, what if I were to say these ports all belong to finance? I can't say, and these plans all go to accounting, and these ports all equal dev test, and these ports all equal production. So basically speaking, I've taken a switch and I've logically chopped a switch into multiple mini switches. That is what a VLAN is. A VLAN is a virtualized switch. So take a switch, chop it into multiple pieces, and you've got virtualized switches. So a VLAN is nothing more than a virtualization. It's virtualization of a switch. I asked Jess. So Jesse, yes, of course, I've got, my home has about 15 of those switches. It's got about 9 servers in it with 24 cores in it. I've got 10 gigabit Ethernet wired throughout my house. We don't even need to know what it takes just to run this application. We're dealing with stuff. Okay. How to segregate subnets, Srinavis? Great question. The second you create a subnet and you put them all in a different VLAN, they can't talk to each other. So subnets can't talk to each other if they're on a different net. So you could literally take a switch, plug all of them together on different subnets, and if every person was in a different subnet, they couldn't talk to each other. So how do you segment to the subnets? Just by being on a different network subnet or different network address. Systems cannot talk to each other. So while Chris is bringing up the next question, if you guys are enjoying yourselves, if you can type cloud hired in the window. Raul, does AWS Solution Architect need to have DevOps skills? Absolutely not. As architects, our job is system design. So we're designing end-to-end systems. So designing of systems does not include configuration of systems. It does not include coding. It does not include maintenance, which is SysOps, and it definitely does not include DevOps. Now, DevOps is an incredibly great career for engineers. It's a great career for the future because it has a lot to do with regards to automation. Automation is the future. So DevOps is an incredible career, but DevOps and architecture are exact opposite sides. We architects design it, and the DevOps people help build it. So hope I answered your question. Chris, are there any others? Networks can't talk to each other without routing if they're on different subnets. They cannot. And that's how we connect subnets together with the router.
There's a question on the screen.
What are the stuffs to take care on VPN design and connectivity? Well, there's two parts of that question. The first part is VPNs are simple. It's just setting an IPsec tunnel across the internet. Now, with regards to VPN design, now you're getting into some place that's a lot different. And here's the reason we're talking about something that's very different. You're talking about WAN design, hub and spoke, fully meshed, hub and spoke plus partially fully meshed. Now there you're getting into some Cisco certified design expert territory, things that would probably take about 500 hours for me to really answer in depth, just talking about how to design a WAN. But as a general rule, a WAN should have no single points of failure, meaning you should have at least two connections. Generally speaking, with regards to network architectures, you should have a core of the network, which is where your high performance routing is. Outside of your core, you should have what's called a distribution layer. So the core is the backbone, and then a distribution layer plugs into the backbone. And then plugging into the distribution layer, you typically have a bunch of access layer switches. Access layer switches are these things. They're these things that have 1,000,001 ports on them. They're the things that you have in the wiring closet. You plug in 500 computers to one of these things. They then go into the next series of switch, which is a distribution layer switch, which aggregates like 10 wiring closets. And then you take that and you feed that into the core of the network. That's the way Cisco designs things. Core, access, distribution. So depending where your systems are, you might do a hub and spoke, you may do fully meshed, and you may do a combination. And that's going to be based upon who needs to speak with whom, the latency of who needs to speak with whom, the kind of routing that you need to do based upon primary, backup, and tertiary paths, the type of engineering that you have to do with your traffic, and the latency required. So those are the kind of things that are really necessary to truly answer that question. So I may do, if you guys desire, a session on WAN design. And if that's the desire, I can probably do a WAN design YouTube live. But it's far too much to cover in just a single week's time. But I could definitely do that because it's probably a great idea. Srinivas, sir, I need more clarity on when we will use a private subnet. Okay, versus a public subnet. So here's the thing. Everything you will do will be in a private subnet unless it needs to be reachable from the internet. Everything that you will do needs to be reachable from the internet. Will have to have a public address in some way, shape, or form. Anything that you don't want to be reachable from the internet gets a private IP address. Are there any other questions there?
Most of the questions are going to be covered in the next sections.
Okay, I think I saw one pop up. As a cloud architect, do you need to know SD-WAN? If you're a cloud infrastructure architect like me, you must know SD-WAN. If you're going to be a cloud architect and be highly successful, BGP knowledge, MPLS knowledge, SD-WAN knowledge is really valuable. Okay, so I'm ready to move on to the next topic. I've been told I've asked enough questions. If you're enjoying this content, if you can hit the like button, inform others, and share, I will switch to a little bit of knowledge in the VPC, and then Alonzo's going to do a lab. Unless, would you guys prefer content first or lab first? Because we could do it either way. Let me know in the chat box. Type content versus lab. Content or lab. And we'll give you both. It's just no matter which order you want. Let's see what we get, Alonzo, in the chat box. We're always having fun teaching.
This is where you have to politic for yourself, Alonzo.
Okay, so
All right, yeah.
lab.
Going for votes.
Let's see what the votes are.
Uh-oh, it's neck and neck. Content.
Neck and neck, you know.
Lab.
If more people want you to do the lab, we do the lab. If more people want the content, we'll do
More
the content
content.
lab.
You'll get
We're
it
definitely
either
going
way.
to cover. Both going to cover the content and the labs. It's looking right now that people have heard my voice for a little while and are saying Alonzo Lab. Even Derek, you know, even called you out by name, Alonzo Lab. So
I am the people's champion.
Guess what? Alonzo is going to go do a lab for a few minutes. And then after Alonzo's lab, I will talk about content. So let's make sure we make you guys all have fun. That's why we're here. Now have a good time to learn and to help you guys build careers. So we're going to do both. Alonzo, take it over to you. I'm actually going to get a glass of water while you expertly show off your great cloud architect skills.
Okay, Mike, go and hydrate. Okay, everyone, if you all are following and you have your management control screen up, you're free to follow up, and we'll continue to move forward. So I'll give you just 60 minutes to get your screen going, and then we'll follow suit and get some VPCs going.
60 minutes, huh, Alonzo?
I mean, 60 seconds. 60 seconds, not 60 minutes. It's not going to take you that long. So everybody gear up. Let's go. Let's get the management console up for 60 seconds, not 60 minutes.
Yeah, that's a great question. Hey, you know what? We could do training all day. I always find it hilarious and fun. I find no better experience than being able to share knowledge. You know, while Alonzo's getting that up and you're all doing it, to me, I've been in tech for so long, I can't even remember. In fact, when I work, remember the token ring, this little thing that IBM invented that moved the little ball to different slots, click, 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 click. So, you know, they were the folks that trained me. And for me, it's about let's train the next generation of really fantastic technology professionals. I live kind of around Palm Beach. When the next generation of cloud architects and network architects are there, I'm going to be practicing yoga on the beach in Jamaica, listening to Bob Marley, Ziggy Marley, and songs like Beach in Hawaii, where they're talking about yoga and Ujjayi breathing with reggae. So that's what I'm going to do after the next generation of technology professionals are created. So glad you're here. We want to give you the best careers possible. Take it away, Alonzo. Everybody's got their things.
Okay, guys, we are ready to go. So first things first, if you're in your management console, we are going to go to our VPC landing page, or dashboard, if you'd like to call it that. So here we are. We are at our resources region. We're going to click VPCs. Now, VPCs, this is your kingdom. This is where you're going to be setting up your own personal real estate. You're going to have your own subnets. This is where you create everything that you need to know. This is your fort. And so by doing so, what we want to do first is click Create VPC. And now we want to type in your own personal name that is easy to reference, easy to look for. And since I have multiple VPCs up and running, so I got to be a little, got to add mine to a 02. So we're going to put in our default IP address, which is 10.0.0.0/16. And we're not going to need any IPv CIDR blocks. We're just going to do a default tenancy. This is going to be a very simple VPC, of which we're going to have two subnets. We're going to add a router. We're going to add an internet gateway. And we're going to have a public and private router so that you can understand why you would need a public subnet and why you would need a private subnet. So right now we are creating our VPC. We're going back to the dashboard. So as you can see right here, this is my VPC. This is my CIDR block address, which is 10.0.0/16. Our DNS resolution is enabled, and we're ready to go. So the first thing that I want to do is be able to provide a connection to the internet gateway for my VPC. So we're going to go over to the drop-down area, and we're going to look for our internet gateway. And it's want to open that up. I want to open up extra windows so everyone can be able to easily reference what we're doing at a moment's notice. And if anyone needs me to slow down, I'll definitely be looking at the chats. And if Chris, you could help me with that. If anybody needs any assistance, I'll be more than happy to do so. So now we're over at the, we're going to select our internet gateway, actions, or rather create internet gateway. That would be my-IGW02. And we already have our tags. We're going to create our internet gateway. Now, remember when I was first starting on VPCs, one of the biggest issues that I couldn't understand was that why am I not connecting? But I also have to remember that you have to not only create your VPC, you have to attach it as well. It's all like plumbing. You gotta build it and you have to attach it so that everything can work and connect with each other. So let's attach to the VPC. We have our my VPC 02 that I originally created. We're going to attach that internet gateway. And now we're going to be back over here. So the next thing I want to do is create our subnets. So I want to create a private and a public subnet. Now, when you're doing a public subnet, you usually want to have a public subnet for in the instance that you want to SSH using an EC2 so that you can privately create that compute and that instance back into that public subnet. So you can specifically, if you want to specifically get to the EC2 from your public IP, that's what you can do in that instance for a public subnet. But for a private subnet, say for instance, you are using that same EC2 instance in that public subnet to connect to your database of which you want no connection to an internet gateway or to the internet as a whole, you use that for that particular instance. So let's create a subnet. So we're going to do public subnet. Rather, let me go back here. We're going to create our subnet. We're going to connect it to our VPC, and we're going to say my hub sub. And our preference, because I am in the Texas area, and the best area for me is going to be US East 2A. That's going to be for my public subnet. Now we're going to have our CIDR range as 10.0.0.0/24. Or rather, let me rephrase that. 10.0.1.0/24. Now with this group, this gives us 251 usable IP addresses for this /24. But in the instance of AWS, remember what Mike said, they take 4 off the top and they take 1 from the bottom. So that leaves us with only 249 IP addresses to use in this subnet. We've added our tag here. We're going to create that subnet. Okay. Now, what I like to do is make sure that everything is attached. So our actions, we're going to go to this specific area. Actually, we'll do everything. We're going to, because since it's a public pub sub, we're going to add our NACLs. Okay. Now, because this is public, we don't have to worry about protecting anything. We don't have to worry about locking anything down because we want access to the internet. So what we want to do is look at our inbound rules. And we want to adjust them. Okay, wait a minute. Let me go back, because sometimes this is what I need to do. this is what I need to do is I am going to go and create our subnets, all of them all at once, so that I don't confuse everyone all together. So bear with me as I get this all squared away. Then we have our subnet. Okay. And we're going to create another private subnet, or rather a private subnet to go with our public subnet. And in this instance, because we want to consider about durability, and we want to make sure that this particular subnet is going to be in US2B. We have our name and our private sub tag attached. We're going to create that subnet. Rather, we got to add the CIDR block. So right here in our public subnet, we had 10.0.1.0/24. Now we're going to have a 10.0.2.0/24. And our subnet is created. So now what we want to do is we want to be able to add our route tables. Now, remember before when I was saying about the internet gateway, we need to be able to connect to the internet, and it's all about plumbing. So we want to create that route table so that everything can interconnect with one another so that it can do what it's supposed to do and communicate with each subnet, and the public subnet can also access the internet gateway. So we're going to create a route table, and we're going to call this our public route. We're going to attach it to our VPC 02. Now, it's always important to make sure, especially if you have so much traffic like I do on my dashboards, to connect the right VPCs to your right subnets, NACLs, security groups. It's all about detail, and it's all about making sure that you have everything associated with the right groups. So we're going to tag it as name, public route table, create, close. So now with that public route table, we look at our routes, we're going to add some. Now, of course, that public route is connected to the subnet, to the VPC that of which it's in, but we want to add additional subnets. We want to connect it to itself, 0.0, so that it can all be connected together. Okay. And then that can also be connected to the internet gateway. Save route. Oops, route table. Oh, that's right. Okay. So we're not doing that. 10.0.2.0/24. Sometimes you got to relearn this stuff as you go along, because it's so important to get this right. Okay. I believe that is what we need to do. Okay. Oh man, what am I doing wrong here? Okay. Oh, that's right. We don't even need one here. That's what I'm thinking about my private subnet. So because we're already, as the public route, we're already connected to our VPC. And the VPC is already connected to the internet. So we're good to go there. So let's create a private route.
Alonzo,
Yes.
can you zoom on the view on Google Chrome?
Okay.
Like you get to the, yeah, there we go.
That good for everyone? Okay.
Thank you.
You're welcome. Okay, so now we're on the private route. Now remember here, we do not want this connecting to the internet. So there's no reason to connect it to anything else at all. So we're just going to say private route. And that's adjusted. So let's see, that is, it's always good to remember to name these things appropriately. But now that I remember, I also, the subnet associations, the route here particularly, I forgot that not only does it have to connect to the VPC of 10.0.0.0/16, we want to make sure that it is connected to the internet gateway itself. So I believe that is the right thing going on. There we go. So yeah, it can be a little confusing sometimes, making sure you're dealing with the route specifically, but ensuring that everything is connected with each other is key so that the entire VPC can move and information can flow to the right areas as necessary. So now we're looking at our VPC, making sure that we're good to go there. Subnets. Just making sure our route tables are good to go. Making sure. Internet gateway. Okay, so now that we have our public and our private subnet, what I want to do is add the NACLs. Now, the NACLs is basically the firewall of the subnet, as the security group is the firewall of the instance that is within the subnet itself. So let's take a look at that. So I want to create a network ACL. That will be my pub NACL. I want to associate it with my VPC. The tag is there. I'm creating that NACL. So now the inbound rules, as it is a public, what we want to do is create a new rule to allow traffic to come in.
Walk them through, Alonzo, which subnets you're creating and which ones you want them to go through, like which rule you're creating for your public versus your private. Make it a little clearer if you can.
Okay. Now, in this particular area, we are focusing on our public NACLs. This is going to be our accessibility into the internet. And we'll discuss the private NACL after we create this one. So we want to allow, so we want inbound traffic to come in. Save changes. So now we want to create our private NACL. I'm going to select that VPC as well. We have our naming tag and our value, create NACL. So the difference with this one is that we do not want any traffic into the internet. So we want to create some new inbound rules. Right here, it says allow. We do not want that. Otherwise, everyone can get into our private information and do what they want. So say, for instance, we did a SSH into our EC2. In this illustrative purposes, I can provide SSH, and then I can add my source for my own personal IP so that the only way that this EC2 in the private subnet can be accessed is through my own IP information. Allow. Save changes. So right now, just looking back at our VPC, I just want to recap what I did. I created my own VPC. This is your own personal environment, your own realm, your own fort, if you will, of your own environment of what you want to create therewith. I created both a public and private subnet. The public subnet is going to be an opportunity for you to drop in, say, for instance, a EC2, where only thing that you want it for is to SSH into any private subnets for your EC2s. And your private subnet, say, for instance, that's where you house personal information that you do not want accessible to the internet, which will be your databases or any other information that is critical. Like, say, for instance, some of this database information could be credit card information, HIPAA-related medical documents that is critical for companies to keep private. The route tables also associated with, like I said, I had the public route, which is associated with the public subnet and creates a route out of the VPC into the internet. The private route is focused on keeping the information in the VPC itself, so that it does not have accessibility into the internet, nor can anyone tunnel into that. And the internet gateway is the door to the internet that allows access into and out of your VPC. Your NACLs, again, are going to be your firewall for your specific subnet. You can set those parameters to allow traffic in, like the public NACL, where it's accessible out of the VPC and into the internet, or you can create that private NACL where everything is locked down. Nothing can get in and nothing can get out. And of course, the security groups, if we had any EC2s or we created EC2s like we did yesterday, that would be placed into your subnet of choice. And it will be surrounded by that security group. That security group, say, for instance, it is an SSH specified to only be accessible from your IP address, can be used there. And so back to the VPC, these are a lot of the key elements, a lot of the key resources and services that you can use to create your VPC.
Lonzo, it looks like your audio went out. So,
am I here?
You're back again. Although now you've got a unique screen. Did you have any more?
I think that is, and I wanted to keep it really simple using two subnets, one VPC, and be able to define the public from the private subnet, so that I wasn't going to create any large 3-tier VPCs, but something where everyone could understand the differences and how they can navigate and create those subnets and get them to talk to each other. So if you have any more questions, please, I look forward to answering them.
I think it might be best to wait for a question session until we start covering the content, because a lot of the questions that were being asked are questions related to the content that's coming up.
Okay.
So
I think we should do that. Alonzo, thank you. As you look, note that what Alonzo was doing here is we were demonstrating how to create a VPC. As Alonzo mentioned, he kept the VPC open because we wanted public reachability, because this is a lab environment. Have this been a real environment, we'd be using firewalls to provide perimeter security. We'd have pretty strict rules that we would be doing. So realistically speaking, that's what we're talking about. So your VPC subnets are going to be in a data center. They're obviously going to be regional because, how else would you get a subnet across data centers unless you were bridging VLANs and running layer 2 traffic, which obviously is not something that AWS is going to let you do, like run a VLAN and an 802.1q tag and trunk from switch to switch. Say your private subnets and your VPCs, they're going to be locally significant. So Alonzo, really great job on that, and thank you.
Thank you.
Really, thank you. So if everybody can say thank you to Alonzo Coleman, great cloud architect, appreciate him doing this demonstration. I'm going to get started on the VPC. If you're still here, let us know by hitting the like button if you like our content. If you're not a member, subscribe, convince others to join our questions as well. We'd love to be there. We'd love to share and spread the word of our free training content. So now we're going to talk about we're going to talk about VPCs. In fact, I like BGP so much, I think of VPCs and I think of BGP. Why do I think of BGP and VPCs together? Well, whenever you connect your VPCs together, you're doing peering. Peering is just like working with BGPs. So, because BGP performs peering things. So my brain always associates these two together, and probably there's some good reason for it. So wonderful, Alonzo. So also requires a VPC. So I'm starting to see questions like, you have a big doubt which services require a VPC. Pretty much look at it this way. Everything that you're doing in today's modern world uses the VPC, except for serverless, which is less than like 10% of what we do on the cloud. So almost everything is going to be in a VPC. So
hey,
now
Mike, if it's okay with you, one of the things that I'd like to do is I'm going to collect all the questions that have come in since the lab started.
Okay.
And at the next question session,
okay,
just start with those.
Okay.
And that way we can, because there's several of them that have come through. So.
Okay, well, I haven't been watching the questions as fast as you, and I was trying to frantically answer them in the chat box.
Yeah, you're not going to frantically answer all of them. That's why.
Okay, that sounds great. So let's talk about what are the components of the VPC. Why is the VPC the most fun part for me? This is where your networking is. And the VPC will have routing. We'll have internet gateways. We'll have egress internet gateways. We'll have NAT instances and NAT gateways. We'll talk about elastic IP addresses, VPC endpoints, VPC peering, access control lists, and security groups. So this is one of the more fun topics for me. I love so much about this because, it's networking, and I love networking. So if you like networking, this is great. Realize the network is the foundation to everything. So let's talk about this. The first thing that I want to talk about is the concept of a routing table. Here's what a routing table is. It's a map of how you get to every different subnet that exists. That's what a routing table is. Quite simply, it is a map. And what happens is routers have something called interfaces. Interfaces are realistically network cards. So a router will have a map and it'll say, to reach this subnet, go out this arm. To reach this subnet, go this way. 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 To reach subnet, go this way. So what's going to happen is the router will basically send your traffic out different ports on the router that are all on different subnets. So that's how your traffic gets from point A to point B. You start, you send your data to the router sends it to the next router, 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 and it reaches its destination, and it comes back. If the router doesn't have a route to the routing table, do you know what happens? Here's what happens. You hit the first router, and the router drops your traffic, because if there's no route, it's all dropped. So, want to do this? You want to be able to reach something, you need a routing table. So, realistically speaking, here's what a routing table is going to look like. Now, I manually made this routing table because your VPCs have a virtual router. Why do you need a virtual router? You can't communicate across subnets without a router, because the routers need a routing table. So here's what your routing table is going to look like. You're going to have basically a subnet. Say this is a subnet you're working with, it's local. This additional subnet, this 192.168 subnet, hey, by the way, reach it out interface PCX 123456. How do you reach the 192.168.1 subnet? Go out another interface, PCX 654321, a specific route for that one. Don't know where to go? Have no idea? Take the default route, which is the 0.0.0.0/0, and go to the internet gateway, because that traffic's going out the internet. So routers build a map of the network, and it's called a routing table. So let's walk a little bit more about what some of these routing tables actually look like. Bear with me. And how they work. So, this is the way organizations typically build their routing tables. You've got a data center, and inside of your data center, you've got a bunch of routers and switches and subnets. What happens is your routers use an interior gateway protocol or an internal routing protocol like OSPF. And the routers exchange messages, and they exchange information about their links, and they calculate a routing table, which says how to go places. And organizations use routing protocols to connect to external entities too. So what you can see here is pretty much what you have in every cloud computing environment. You've got basically something on the left, which is an organization's data center, and you've got something on the right, which could be another organization or the cloud provider. So organizations run their own interior gateway protocols. They have their own internal subnets. They peer the VBG peering to someone else, and they connect to external entities. Guess what? This is how you connect to the cloud provider. If you've got a direct connection, you're going to use ABGP peering with the cloud provider, so you can dynamically exchange your routing information. The routers can build a map. The router here knows that to reach this router here, to go to this router, this router, this router. Once it gets to this router is going to say, this is the best path. This router will say, this is the best path. That's how the traffic is kind of routed like the child's game hot potato. Take it to here, pass it here, pass it here, pass it here, until you reach the destination. The router's job is as follows. Get the information, get the packet, and send it out and interface as fast as possible. That's what routers do. In and out. That's how they reroute your traffic. So now you know. So when you're dealing with the kind of information, all of your routing is going to be to build a map of the network. The map of the network is called a routing table. Now you know what the routing table is. Now, let's say you want to make a web app. Let's also say you want to have VPNs. You need access to the internet. So how do you get connected to the internet on the cloud? Well, there's a couple ways. First, we're going to talk about real internet access. Real internet access enables you to go out to the internet and enables people to reach you from the internet. So when you're talking about real internet access, it's not like you're behind a firewall and you go through the internet, the firewall, and your return traffic is allowed out, but nobody can reach you. Real internet connectivity involves bi-directional connections, you to the internet and the internet to you. So how do you do that? How do you get a real internet connection? Here's what you do with a real internet connection. You connect to the internet. How do you get off of your network and connect to the internet? You need a router that's connected to the internet. What is the other name for a router? It's called a gateway. So with AWS, if you want to make your systems available to the internet, you've got to connect them to the internet, which means you need an internet router, which has got a WAN connection to the internet. And in the AWS environment, the router with that WAN connection is called an internet gateway. So here's what you do. You basically take your internet gateway, you attach it to your VPC, you place a default route. A default route is a 0.0.0.0/0 route. It says if you don't know where to go, take this default route. So what happens is organizations will have routers with routing tables. They'll have a path to every subnet. And when you don't know where to go, they go to the internet because they assume it's not local. So that's there. Now, can anybody think of this? And I want you to comment in the window. If I stick my server on the public internet, Does anybody see a problem with that? If my web server is on the public internet, it will be reachable from the web server. If any of you guys can see a concern of a public server available on the internet, type that concern in the chat box right now. What is the problem of having your servers 100% reachable on the internet? So when you attach an internet gateway, if you don't do anything else, the servers in your public subnets will be on the internet. So we've got a problem. Judith seemed to figure it out. When our servers are reachable from the internet, they can be hacked. So, Benina Kala for a hand of God. For the rest of us, this is not a good thing. Not a Katholu. It's not a good thing. So what's going to happen is as follows. We're going to get hacked every day of the week. We don't want to get hacked. So here's what we do. We use security protocols. We use firewalls. We use IDS systems. We use serious stuff. And we'll talk about this. But please know, when you're fully connected to the internet, you will get hacked. And there's a lot of hacks. There's DDoS attacks, there's privilege escalation attacks, there's all kinds of attacks, buffer overflows, and we will get them all very fast. It's not secure. If I look at the firewall in my house, people try and hack me 20, 30, 40 times a day. So like Alonzo said perfectly, you opened a door to your front house in a busy city and said, welcome everyone. And by the way, it's like hanging in a sign that says, guess what? Here's money over here. Here's these other highly priced things. Here's jewelry over here. Welcome. So no, when you're using an internet gateway, you've got to think strong about security. You've got to build solid security into your architecture. So just wanted you to know that. So an internet gateway is quite simply a router that connects to the internet. So let's look at it this way. Here we've got our instances. And here's the virtual router, which is connected to the internet gateway. Our systems know to go out to the internet. That's it. That is a true internet gateway. A true internet gateway provides coming in and coming out. Well, this will be coming in and this will be going out. But basically, that's what a true internet gateway does. Now, let's talk about the alternative. If you're dealing with IPv6 in the AWS cloud, they have something called egress-only internet gateways. Egress-only. Who thinks of these terms? Egress means exit only. So, an egress-only internet gateway lets you go to the internet and it lets your traffic return. But it blocks people from the internet coming with you because it's egress only. Traffic into your systems is ingress. Traffic leaving your systems is egress. So an egress-only internet gateway is basically a one-way connection to the internet for IPv6 in the AWS. It allows your return traffic to go out and your traffic to return, but it doesn't allow external people to connect to you. A lot like a firewall without the firewall security. Same concept. So with AWS, an internet gateway gets you bidirectional communication to and from the internet. On AWS, an egress-only internet gateway only allows your exterior traffic to the internet and come back. Let's think about where this would be appropriate. If you want your systems to be protected from the internet, but you still want them to reach the internet to update their operating systems or get a security patch, an egress-only internet gateway is your best friend. Think about it, though. An egress-only internet gateway is your best friend. This allows your systems to go to the internet and get their patches and come back. So with IPv6, we're not talking about NAT. This is just the way it works. NAT could also enable similar functions like this, but NAT has many other functions that are not related to this. For example, NAT could be used when connecting to organizations with overlapping IP addresses. NAT could also be used when you're connecting to multiple VPCs. NAT's got a lot of uses other than just this. But yes, egress-only internet gateways, IPv6 out and coming back. Now, there's two other things that you can actually do with AWS. There's the concept of the NAT instance and the concept of a NAT gateway. They both have pretty much the same thing, but the way they do them is differently. The old way to do this is to take a NAT instance, and it's a virtual machine you can get from AWS. It's on an AMI, it runs on an EC2 instance. You basically put the NAT instance in a public subnet with a route to your internet gateway. And what happens? Your internal systems use the NAT instance. The NAT instance translates it to a public address, and your traffic is routed out to the internet. Now, this is egress only when you're using an internet gateway with a NAT instance. So it allows your stuff to go to the internet and allows your return traffic to come back. This is a perfectly good way to do NAT. Here's the thing. In this particular case, you've got the NAT instance and you've got the internet gateway. Totally appropriate way to do things. Not the newest AWS service, but it works perfectly. People like me have used this kind of environment for years. So we've got a router, we've got another router doing NAT, and we've got our private stuff. Works perfectly, but is not the AWS preferred way. Note, with this environment, you've got the internet router and you've got the NAT instance, but it works perfectly. So AWS came with a fully managed service. AWS likes to do things where you click one button, it does everything for you, which is one of the great conveniences of the cloud. Another thing that's not so good about the cloud, they try and do as much of it for you as possible, which means a lot of the tuning, a lot of the coolness, a lot of the things that you want to do, you're going to have to work around the limitations of the cloud because they try so hard to do everything for you. It's kind of like when I use my Mac. If I need to do anything cool, I can't because I don't have access to the cool stuff. That's why for stuff that I need to do that can't be done on the cloud, I have my own data center, my own private cloud. But the cloud makes it easy, which is why we're going there. It's simple. It's elegant. The cloud is about 89,000 times easier than what we used to have to do. So it's fast, it's simple, it's elegant. So AWS decided to make it simpler. And they came up with something called a NAT gateway. And this is really a nice, simple, elegant solution. It's basically a single router that does your NAT and connects you to the internet for egress-only traffic at the same time. So instead of using a NAT instance and an internet gateway to give you this, the NAT gateway does it all as a one-stop shop. It's really kind of cool. You've got a single service that connects you to the internet and translates your internal addresses to your external addresses in a one-to-many NAT capacity, meaning you can have all your addresses all translated to one. This is also referred to as port address translation. Now, NAT gateways are cool because they are very simple and elegant. So, architecturally, let's look at it. We've got our private subnet, we've got the NAT gateway, and it's directly connected to the internet. So all we need is the default route to the NAT gateway, and everything will work. Hope that kind of makes sense. So now, we talked about everybody having a routing table. We then talked about different ways to connect to the internet. We talked about using an internet gateway for direct internet access. We talked about using an egress-only internet gateway for IPv6 egress-only traffic, meaning out to the internet and back. We talked about using a NAT instance and a NAT gateway. A NAT instance and an internet gateway as a means to use the NAT instance to translate your addresses and the internet gateway to connect to the internet. We talked about the new and modern replacement of the NAT instance plus the NAT gateway, and the NAT instance plus the internet gateway called the NAT gateway. One-stop shop, does your NAT and connects you to the internet. Those are the types of ways that you could connect your organization's VPC or virtual private cloud or virtual private data center. And that's what's going on. So let's talk about some new things that are part of the VPC. So somebody before asked what's the difference between elastic and scalability, and I said elastic is just a marketing term that doesn't mean anything. If you want to get a network interface in AWS, they call it an ENI, or Elastic Network Interface. Strip off the word elastic and you know what it is, a network interface. What is a network interface? It's a network card on your server, an Ethernet card. Now you know what an elastic network interface is. Strip off elastic and you know what it is. That's why when we're really talking about architecture, we get rid of the buzzwords, we get rid of the names, and we call a spade a spade. We're talking about a network interface. So what happens is when you boot up a system, it comes with a network card, because how else would it work on the network? So it comes with a default Elastic Network Interface or network card called ETH0, pretty much your standard Ethernet port. Now, if you wanted to put a server in multiple subnets, you could add multiple elastic network interfaces. Now, lots of reasons you could do it. There are times where organizations will want to put multiple servers. Good business reasons. Now, there is a bad business reason to do this called the Bastion host. A Bastion host is probably the worst idea you could possibly think of in the entire world. It is a security nightmare and is something that no one should ever do. A Bastion host is you stick a server unsecured in the middle of the internet, and you allow someone to SSH into this non-firewalled off server. And after they SSH into this server, it's got a second network card, and you can use that back end of the network card to pass your firewalls and go directly into your network. This is insanity. It's great for a test. A Bastion host is a host that sits on the internet. It's got 2 network cards or 2 elastic network interfaces. You go straight into that Bastion host. You go out the back, secondary elastic network card into your network. You violated all of your security, and poof, you're in your systems. Of course, any hacker that's worth their salt in about 10 minutes can violate your systems and break into your Bastion host. So never, ever, ever, ever recommend a Bastion host. Do your connections, do your configuration and maintenance over your IPsec tunnels or your direct connections with IPsec running on top of it. But an elastic network interface is a network card. You stick 2 network cards in a server, it's called dual homed. If you decided to make a Bastion host, and I beg you not to do this if you don't want your customers to get hacked, here's what you would do. You would create a server, you'd put in a second elastic network interface, you would go in the first interface, the publicly available one, and you would use the back end, that secondary network card, to bypass your security and go straight into your system. So the net result, when you have more than one card in a server, it is called dual homed. If you've got multiple cards, it's called multi-home. So outside port, inside port, if you put multiple cards on a server, guess what? It will be called a multi-home server. But the Bastion host idea, don't do it. The jump host idea, don't do it. But that is a perfect example of a dual home server. But there are lots of good reasons to do this. Now, anytime you want to connect to the internet, you need a publicly facing IP address. It must be globally routable. So, normally speaking, it would be called a public IP address. But with Amazon, here's how you remember it. They have some other name for a public IP address. If you're in doubt with AWS, stick the word elastic in front of something and you'll have its name. What do you think AWS calls a public IP address? An elastic IP address. An elastic IP address is as following. It is a public IP address. So now what AWS does here, which is really, really cool, is as follows. AWS lets you borrow their address. And this is really, really, really cool. And I'll address Babita why people use Bastion host, although really it's mostly just in lab and almost never done in production. And the only people that are teaching the Bastion host are the people that have not worked in the production. So we'll explain to you why later that is. And I'll show you what people do instead. But realistically speaking, the elastic IP addresses are the public addresses. Why is this so cool? Because AWS lets you borrow that address and keep it as long as you need it. You want to stick it on a network interface? Great. You can keep it there. You can put it on your web server for the next 5 years. You can put it on your load balancer for the next 5 years. There you go. It's that. So, and when you're done with it, it goes back to AWS. You don't have to apply for public addresses. You don't need static addresses. It is the most simple and elegant solution. AWS renting you an elastic IP address is absolutely amazing. Simple, elegant, fast, and I absolutely love it. So I may not be Mr. Marketing, and I might like to call a bear, and a cat, and an IP address to IP address. But this concept of borrowing an address when you need it is really, really great. So let's go over the 2 kinds of network addresses we've talked about. We've talked about an elastic network interface, which is just a network card. We've talked about an elastic IP address, which is a public address that gets placed on one of your interfaces. Now you know. Now let's look architecturally speaking at what is an elastic IP address. We'll work through it. Let's show you. So basically speaking, you've got your instances here. Let's assume this is a little bit of a load balancer here, load balancing. We've got this 3.3.3.3, which is a public address. That is the elastic IP address that will represent our servers, all of them. And that will go through our internet gateway and it will be sent to the internet. And guess what? Everybody can communicate with each other. So there we can go. So I think we've covered some elastic IP addresses, some NAT instances, some NAT gateways. I've got more that I want to talk about on VPC, such as endpoints, but I think we should open it here for a few minutes of questions and answers. So Chris, if you want to bring it up.
Yeah, so can you hear me?
Yes.
Okay, so some of the questions have gone out of my, I guess you call it, portal. So luckily I pasted them to myself earlier. So I can't pop them on screen, but I'm going to read them out loud.
Okay.
And you can simply say, you can answer and review, or you can say that might be coming up if it's something that's coming up, of course.
You got it.
And if you want to switch back to big U instead of little u.
That sounds good.
All right, so the first one, this one came in during the labs, towards the end of the lab. Once a VPC is created, what kind of default elements are created?
Well, Lonzy, you want to speak to that because you were just configuring it? Because typically your VPC is going to create your subnets. Inside of your subnets which you specify, that's where your access lists are going to be. That's where literally everything is going to be there. So
Right. Normally with AWS, you're going to have your default VPCs that come with the actual VPC that you spin up, but you can delete those and create your own at will. So say, for instance, you have your VPC, that's your full environment. And then within that, you can make your own subnets, public or private, interconnect them with the router, and make sure that the internet gateway is accessible so that everything can communicate in and out based on your NACLs and your security groups.
Okay.
Sounds great. Okay, Chris, let's go to the next one.
Yeah, the next one is, can you explain the concept of an ephemeral
port? You got it.
In association with NACL rules.
So here's what an ephemeral port is. Certain things are very easy to create a firewall rule or an access control system rule. Allow IP address X to reach IP address Y on port 443. Allow X to reach Y on port 80. That's a standard no port. An ephemeral port is allow X to connect to Y with some temporary port that's only going to be there for 3 seconds and it's going to change at the end of the session. When you're dealing with ephemeral ports and you're dealing with things, it's going to really complicate the types of things that you can do with your access control list, because you're going to have to specify a range. And when you're specifying a range like that, it's going to be a big range and it's going to open it up. So what you typically want to do is make sure you've blocked everything you can with your firewalls, everything you possibly can to protect the systems from with your IDS, IPS systems. And then when you allow those ephemeral ports into a subnet, you make sure that those hosts have whatever host-based firewalls they have. You make sure your intrusion detection, intrusion prevention systems are searching for anomalies. So if they can sense something that looks like a bad pattern of behavior, they can thwart the attack. So when we're talking security, and we're going to get into security, I don't want anybody thinking security is WAF, Shield, and NACL in a security group. That doesn't even come close to talking about enterprise-wide security. Look, the web application firewall, awesome. Shield, awesome. Network ACLs, awesome. Security groups, awesome. But, you know, that's only a very, very, very small part of security. So when you're dealing with big gaping holes like this in ephemeral ports, you're going to have to get really strong and really specific on the security, because otherwise you're in trouble. Great question. You want to bring up the next one? And I'll actually walk through why never to do the Bastion host as an example when we get to that. But let's keep
so for an S3, which doesn't fit to VPC, how can it interact with VPC elements?
Okay, we're going to get to that. What happens is you're going to create an endpoint. And there's basically two kinds of endpoints. There's gateway endpoints and interface endpoints. And what you do is you're going to create a route to the endpoint, and it's going to be in the routing table. And I'm going to show you exactly what that looks like when we cover VPC endpoints, which coincidentally are coming up next.
Yep. All right. So the next one is, can can you clarify something since we learned in part one, day one, that VPCs are private space you carve out from the public cloud? Does that mean you will launch your VMs, databases, etc. in the VPC?
Exactly. Your
Okay.
VPC is effectively like your virtual private data center, and all the stuff that is yours will be inside of your VPC. An organization may have to have many VPCs if they're segmented. It's not uncommon for me to look at an organization with 1,000 VPCs. So, but yes, all your
Okay.
stuff is inside of a VPC.
Perfect. If you have a private network where nothing goes in or out, what would this be for? What is its importance?
Okay, so look at it this way. Let's say you work at a hospital, or any business for that matter. The hospital has to keep their patient records. The hospital has systems where I order a prescription for my patient. When I order labs of my patient, like blood chemistry, I want to be able to look at the blood chemistry. If I order an MRI on my patient, somebody's going to do a scan, and it's going to be then sent in an imaging system where it's called the PAC system, where I can view my internet. None of that needs to be connected to the internet. Right. So realistically speaking, 90% of an organization's businesses will not be on the internet. You don't want any of your internal systems on the internet. All your critical infrastructure is not on the internet. For some people, the only thing they have on the internet is just a website to basically let everybody know that it exists. Everything that matters is going to be private. Your intellectual property is going to be private. Your manufacturing is going to be private. Your patient data is going to be private. Your customer's financial data is going to be private. All that needs to exist in private internal systems.
B3 Collector said critical infrastructure. Pretty much
perfect way to put it.
Yep. The next one is Bastion host, but you already said that you're gonna. That's not the one that caught your attention. So I'm just gonna skip it anyway.
I'm gonna do that in a minute. I'm gonna whiteboard out why it's the worst idea in the world and never used by anybody that has a real business.
And the next one is, how could you have different availability zones for different subnets in a VPC? In the demo, the private and public subnets used different availability zones.
Well, a subnet is going to be local to a geographic area. So realistically speaking, if you've got two data centers, the only way you could have them on the same subnet is if basically you had users in one VLAN on one side and users in another virtual LAN, and then in between them you ran a layer 2 trunk with like an 802.1q tag or an ISL tag, some way to keep it separate, and that would be a layer 2 network. Organizations don't do large layer 2 networks because layer 2 networks are prone to loops and broadcast storms, which are really, really ugly. So AWS will route in between availability zones, which means, of course, if you've got two data centers, they have to be on separate subnets.
All right, and the last one that I had collected before the Bastion host one was, what is the function of a VPN and VPC, and how is the application?
Okay, well, VPNs or virtual private networks are ways where you can send your information privately across a network that's public. So an IPsec tunnel, an encrypted tunnel between 2 points on the internet where you're passing your private information, and as part of their private access to information. So realistically speaking, that's what we're talking about. Now let's talk about why Bastion hosts are such a bad idea. And I'll show you what organizations can typically do that care about security versus organizations that don't. So let's go over here. I will actually create a new slide and we'll walk through the secure way to manage your infrastructure versus what you've been taught to do by a lot of the certification course providers, because they are very, very different. Here's what a well-architected, high-security environment looks like. You've got your data center over here. You've got your cloud, your VPC. Inside of your VPC, you've got your servers. Let's call this servers. Call it server. And these are production servers. So in real life, I've got a direct connection between these two facilities. So if I am the user and I want to manage this server, I leave my data center, I stay on my private private line. Through my private connection, I'm already in my VPC, and I'm administering the server. Now, this server, to let you know what we've done, this server has got a firewall first. Behind the firewall, let's really, so you can really see what a well-designed security, what a well-designed web host app is going to look like. So the first thing we're going to have is we're going to have some DDoS. Then we're going to have a firewall. After the firewall, we're going to have an IDS IPS system. Behind the firewall, we're going to have a network access control list. This is real security. So let's move this stuff to the bottom because I've got a lot more security to put here. And I'll show you why the Bastion host is something you should never do on anything other than a certification exam. Behind the network ACL, we've got a security group. And we'll talk about that in a minute. And then on the server, which is our web server, which is coming up next, here's what we've done to the web server. On our web server, we've disabled all unnecessary services and ports. Then, after we've disabled all unnecessary services, we have a host-based firewall into it. So we've got a host-based firewall. So disable services. Now, let's say we put a host, well, I'm not going to be Mr. Spelling today. Let's say we've got a host-based firewall, Let's say we've got some anti-malware protection. Look how protected this server is actually from the internet. We've got DDoS protection, we've got firewalls, we've got IDS, IPS systems, we've got network access control lists, and we've got security group. We've disabled all of the unnecessary service. So pretty much we are locked down. Here's how you manage the systems. You go through your private line, secured private connection directly into your systems, and your systems are 100% really locked down. Now, let's say besides this, we had this great idea because we took some training and it said, let's use a Bastion host. All this security goes away. Here's now what we have. We've got now some computer literally sitting out there in the middle of the internet. And it's not a specialty security appliance. The one from Azure is a lockdown security appliance, more like a VPN concentrator. But the Bastion host that most people are doing is as follows. They just stick this little server directly on the internet. The server's on the internet. You can't have a lot of firewalls and IDS and IPS systems because it's a Bastion host. You got to leave it out there. So now you're sticking a regular computer on the internet. You've skipped all the layers of enterprise security. And this Bastion host, this crazy idea, let's see. You've got all you have to do is now access this Bastion host, and straight from the Bastion host, you're going directly into your server. So unsecure system in the middle of the internet, connect to your server. Now compare this. You can only go through your private connections, and you've got to beat your DDoS, your firewalls, your IDS, IPS systems, your network ACL, security groups, a host-based firewall, anti-malware, and unnecessary services. Wait, Bastion host, just go remote desktop into some Windows host in the middle of the internet and bypass your firewalls, bypass your IDS, bypass your security groups, bypass your NACLs, bypass everything, and now you're on your internal network. Does that sound like a good idea? Lose all your firewalls, lose all your intrusion detection? I wouldn't do it. Why do people do it then? If you don't have the connection to the cloud provider, like in a lab environment, you don't have a way to do this over the direct connection. So if you're building a lab environment, like in a certification course, they'll say, here, create a Bastion host or a jump host and try it out. That's the only way you can get onto your systems through the command line. But in real life networking, in real life cloud computing, this idea is so dangerous that you would never want to use it. So As cloud architects, it's not about knowing the name of the service and how to configure it. It's knowing what's in the best interest of your customers. How do you give them next generation technology? How do you give them the concept of security? And you do that by segmenting them, by locking them down. If everybody understood why I like high security and why being a cloud architect is about real depth of knowledge, and you understand why we're talking about this from a security perspective, before we go to the next thing, hit the like button and please put cloud hired. So now you know why we don't use Bastion hosts as a rule. And we will definitely talk about load balancers as well as DNS and everything else. So we'll definitely get to that. So if you're enjoying this content, hit the like, hit the subscribe button, and let me know by typing hashtag cloud hired. And then after that, we will go back into the content. Okay, I'm starting to see you guys are getting it. Please keep me know. I don't know how you added the cloud to that cloud hired, Abigail Marks, but that is pretty terrific. So if you're here, let me know. That way I know everybody's awake, alert, and oriented. Now for we medical people, we typically do awake, alert, and oriented ×3, alerting to knowing who your name is, basically what the year is, those kind of things. So, okay, I see you're there. I know that you're awake, alert, and oriented. We can keep having fun talking about things. Excellent, excellent, excellent. We're talking about tech. It's party time to me. I love tech. I hope you guys all love tech. For architecture careers, it's good if you like tech because we're going to play with a lot of it. Now, let's talk about VPC endpoints. What a cool idea this is. A VPC endpoint is a way that you can connect your VPC to other VPCs or an AWS service. We love talking about endpoints because it's kind of part of networking. And networking is fun. If you like networking, type networking is cool in the chat box. If you're a CCIE like me with a number of less than 10,000, when you were old enough to take a 2-day test that was 90% failure rate, you're going to love networking like me. So let's talk about the VPC endpoints and why organizations use them. Secure, high performance connections, low latency, low cost, and high security. So it goes back to the same kind of thing where we talked about not using Bastion hosts. Let's talk about a VPC endpoint. Let's walk through the situation. S3 is not local to your VPC. It is a public endpoint for AWS services. If you didn't have an endpoint, here's what you would have to do to have your systems use S3. You would have to have your VPC, your traffic would have to go out an internet gateway, your traffic would go across the internet, your traffic would come back into AWS S3. So now I really, really want you to think about the complexity of this. If you didn't use an endpoint, you have to go to the internet, which means egress traffic. Amazon charges you for egress traffic. So you're going to send your traffic to the internet. Actually, they charge them a lot. They can charge you ingress or egress depending upon where. But as a general rule, they don't charge you to send your data to AWS, but they charge you to send it out. So you will pay for the traffic to go out to the internet. Your traffic will cross the internet unencrypted and insecure, and then it will go back through the internet back into AWS. So you got network charges in using the internet. Remember yesterday when we talked about direct connections versus VPNs? And we said direct connections offer guaranteed performance and bandwidth. And VPNs are best effort because they're based upon the internet. Where do you want to send your data? Down a high-speed highway or down something with a bunch of bruises along the way? You want to send it down the highway, not with the bumps and bruises. So by using a VPC endpoint to S3, you can ride the Amazon private network, which Amazon is in control of. The internet, nobody's in control of, so your traffic is best effort. But when you're on the AWS network, AWS has really good network engineers and really good network architects and a really good network. So your data is going to traverse their network in the right way. So that's why organizations use endpoints. Without endpoints, we'd have to use the internet, or we'd have to get a direct connection to them, and that would get expensive. So let's talk about endpoints more, because endpoints are cool. There's two kinds of endpoints. There are gateway endpoints and interface endpoints. And endpoints, like everything else in AWS, are virtual devices that are relatively high availability, highly redundant, and highly secure. So the types are gateway endpoints and interface endpoints, and they are a little bit different. So let's make sure you know. A gateway endpoint places a route in the routing table, so it works via regular routing. A gateway endpoint is a high-speed, high-security access to an AWS service. So when you're dealing with an S3 endpoint, remember, it enables you to have private access to S3 to and from your VPC. When you're going to create an endpoint for S3, what happens is a prefix list is created. The prefix list tells you how to get to your things, and the VPC endpoint is created. The prefix list will adhere to a naming convention that looks like a PL whatever, and you'll see it in the routing table. It will be a route to S3, and it will work via generic routing, the kind of routing I've always done forever, route to your stored data in S3. Won't be an IP route, but it'll be something like it. Now, when you're dealing with gateway endpoints and you're dealing with security, you're dealing with routing. Remember, why do I love routing? Routing gives you access to everything. I want you to really think about it. If you don't have a route or a path, you can't get somewhere. So if I wanted to drive to my friend Ian's house, Ian was one of my cloud architect students. He's a great cloud architect, recently got a great cloud architect job. If I want to drive to my friend Ian's house in London, I can't. Why can't I drive to Ian's house? There's no road. So I can't reach Ian directly. Now, I could buy an airplane and reach him via airplane, but it's a lot harder to do it. I could get a boat and I could go from Florida to London, but again, it would be hard because I'd have to sail across the Atlantic Ocean and it would take time. So by using a route, you can really enhance your security. With routers, you can limit routes to people that need it. If you don't have a route to it, you can't reach it. If you can't reach it, you can hack it. So think about when you're dealing with gateway endpoints and routes and routing tables, you want to lock your systems down? It's real easy. Keep them from having routes to the destination and everything will be perfect. That's how you get to ultimate destination. So now you know about gateway endpoints. Now, let's talk about that other kind of endpoint. Let's talk about that interface endpoint. So, interface endpoints are a way to connect to different AWS services, such as the EC2 Systems Manager, Kinesis, Elastic Load Balancer APIs. External services could be used by AWS partners, etc. You could be using interface endpoints for that. But an interface endpoint works differently. With a gateway endpoint that you use for, say, S3, it places a routing table. With an interface endpoint, it creates a network interface inside of your VPC, like another network card. So it places an additional subnet. Now, when you're using these interface things, it creates like a private link connection or a wire between you and the other service. So an interface endpoint basically puts a network card on both sides of the connection on the same subnet. So interface endpoints do traditional IP routing by placing a network card on both sides of the equation. That's an interface endpoint. So when you create an endpoint, because it's going to have an IP address and a subnet, it's going to give you a DNS address. So this is really, really great. So now you know about endpoints, interface endpoints. So interface endpoints use that private link service, and effectively they create a virtual private line. Now what's cool about this? Lots of things. When you create a link to somebody else and it's a private link, it's assuming you're dealing with private networks. What do private networks address space use? Private networks all use something as specified by RFC 1918. You know those addresses we just talked about? Something from the 10/8 address range, something from the 172.16/12 range, something from the 192.168/16 range. So you got a problem. Company A buys company B, they've got overlapping IP addresses, they can't talk. What do? They either readdress everybody or they use NAT. So when you're using interface endpoints that creates a network card on both sides of the equation, these systems automatically do NAT. So you can connect to somebody else, they're using the same addresses, you're using the same addresses, private link automatically assumes you are anyway, whether you are or not, creates NAT, places on a subnet inside of your VPC and something inside of somebody else's VPC, and everything works. It is a simple, elegant, beautiful, beautiful solution. So let's look and see what this realistically looks like. Okay, so in this environment, here's what you can see. We've got one VPC of one customer. We've got another VPC of another customer. In this case, VPC2 is sharing a lot of services with VPC1. So what we've done is we've taken a network load balancer and we've used it to load balance a bunch of servers in VPC2. And now VPC1 connects to VPC2 over this private link service. They get fast, secure, high performance networking services in between virtual private clouds, in between virtual organizations. So this equals awesome. Really, really awesome. So this is how it works. Now, we will talk about VPC peering, but private link is a little different than VPC peering. Private link enables you to connect to a service or an external entity. Private link does not. Private link uses routing to connect. So private link is a great way to connect to VPCs. Oh, wait, there's this concept of VPC peering, which can also be used to connect to VPCs. See, when you're dealing with architecture, there's usually a lot of different ways to do things. And you have to select the best one for your customer to optimize their business. So it's not like memorize services. It's about know how to solve the customer's problem, know how to make the customer's business better. So we talked about private link. How is private link different than VPC peering? Well, I'll tell you, it's different in a lot of ways. Well, first, private link gives you access to a simple, specific service. So if I connect two VPCs with private link, I could say you have access to this server that has souvlaki recipes, but nothing else. So very specific service. VPC peering is like, let me connect my New York office and my London office and share everything. So private link, specificity, VPC peering, everything. If you need to share multiple services, use VPC peering. If you only need to secure one thing, use private link. Now let's talk about VPC peering. VPC peering only enables you to connect to 125 connections. That's nothing, literally nothing. 125 VPCs, it's nothing in the grand scheme of things when we're talking about networking. Private link is much, much, much more scalable. If you need more than 125 connections, and getting that with VPC peering is nothing, especially when we're talking about fully meshing. That's nothing. Private link scales. Pretty much the limits are based upon the maximum throughput achieved by load balancers and servers. So it's almost unlimited scaling. Private link, as I mentioned, solves the problem of overlapping IP addresses because private link uses NAT. Now, one of the things with private link that's a little odd is it's unidirectional. So let's say I wanted to set up my VPC to have recipes for hoyatiki salatas, which is a Greek salad, souvlaki, which is a Greek food, and fasolaki, which are Greek green beans. I wanted to share the recipes for that and nothing else. With private link, I could basically make it that people could access the information from me, and I would still have no access to their systems because it's unidirectional. Now, I think it's Hand of God that's somewhere in Greece. And let's say Hand of God by I think that's your name via YouTube. Let's say you're over there in Greece right now. And let's say we wanted to share information and I wanted to it was head over heels. I'm so sorry. So head over heels, let's say I wanted to connect to you in Greece. And while I'm an expert on making souvlaki and hoyatiki salatas and fasolaki, which is Greek green beans, you're an expert on everything else. So I enable you to connect to get my recipes, and I reach out to head over here's recipes in Greece. That person shares them. So we can set up private link in one direction or both directions. With VPC peering, we're sharing everything. So understand that's kind of the main difference. So now let's look at VPC peering. What is VPC peering? VPC peering is one of my favorite things. It's when you take one virtual private cloud and you connect it to another. Why do I like it so much? I built a career working with BGP. BGP peering, VPC peering, kind of the same. So Let's talk about it. So VPC peering is used to connect to multiple VPCs. Now I want you to really think about how cool this is. If you connect multiple VPCs across the AWS network, what do you get? AWS network performance. Wow, that's good. So it's not like internet performance. You can do it over the private AWS network, which will give you much, much, much better networking performance. Now, VPC peering is not transitive, and we're going to talk about that in a lot more depth, but I need you to understand this. VPC peering is not transitive. What that means is, let's say my head is router B, my left hand is router A, my right hand is router C, and my head is router B. In non-transitive routing, if I learn a route from router A and it goes to me, router B, I will not send that route to router C. If router C does not know how to reach router A, they won't be able to communicate with each other. So in non-transitive routing like VPC peering, if I learn a route from one person and I take it in, I don't give it to someone else, so they're not reachable. So if I want people to be reachable or VPCs to be reachable in cloud computing with VPC peering, I have two choices. I must fully mesh them, or I must break the rules of VPC peering. So let's show you what VPC peering is first, then we'll show you how to break the rules, because this kind of stuff is important. So let's take this particular situation of VPC peering. Here we've got one VPC on the left side, a VPC on the right side. We've set up VPC peering, and they are exchanging information back and forth, and everybody's happy. Life is good. VPC peering is not transitive. Is it a problem here? Not one bit at all, because we've got a VPC on the left and a VPC on the right. The VPC on the right knows all about the left's routes because it got them because they're directly connected. The VPC on the left knows all about the VPC's routes from the right because they're directly connected and they are shared. Because they are shared, everybody knows how to reach everybody. This is good. This is what we want. Now, I'm going to go back and I'm going to say this again. VPC peering is not transitive, which means if I learn a route from somebody else, I don't give it to somebody else. So this changes everything. VPC peering, unless you break the rules, will not work in a hub and spoke environment. It requires something called full mesh. And I'll show you what that looks like. Here is the problem with full mesh. The more devices you have talking to each other, the more connections you need. And it goes up exponentially and fast. If you ever want to know how many VPC connections you would need to fully mesh your VPC peers, it gets ugly fast. The formula is n times n minus 1 divided by 2. N times n minus 1 divided by 2. So if you had 100 VPCs, and 100 VPCs is absolutely nothing. Nothing. It's pretty common, and big networks have 1,000 VPCs. But let's say you only had 100 VPCs. If you had 100 VPCs, 100 times 99 equals 9,900. Now divide by 2. That would force you for 100 VPCs to do fully meshed to have 4,950 pairing connections. 4,950 to connect just 100 VPCs. Now, how many VPCs does AWS allow you to pair? 125. So you couldn't deal with this under any circumstances. So VPC pairing is not transitive. And because it's not transitive, just like IBGP, it gets ugly really fast. So let's walk through this. Let me show you the architecture, and then I'll show you what we do about it. Because don't worry, it works. We've got a workaround to every problem. So in this particular case, I want you to look at this. This is non-transitive routing at its best. You've got VPC-A in the center. VPC-A can reach VPC-B, VPC-C, VPC-D, VPC-E, VPC-F, and VPC-G. That's great. And VPC-B can reach VPC-A, and VPC-C can reach VPC-A, and VPC-D can reach VPC-A, and VPC-E echo can reach VPC-A, and VPC-F can reach VPC-A, and VPC-G. But now, can VPC-B talk to VPC-B with non-transitive routing? Let me know in the chat box. If VPC-B with non-transitive routing cannot talk to VPC-C, in the chat box, type no communication. And if they can talk to each other, type communication. So in this non-transitive routing environment, if VPC-B can talk to VPC-C, type connected. And if they're not, type no connections or not routable. Let me know so I know you've got this, and then I'm going to teach you the workarounds. Okay, Judith, exactly. They can't talk to each other. Head over heels. Polikala, they can't talk to each other. Victor, no, they can't talk to each other. Amrath, you are correct. They cannot talk to each other. Hand of God, they can't talk. Evo, no talk. Brenda, they can't talk. SM7, they can't talk without us doing something to break the rules. And you've mentioned one of the ways to break the rules. Exactly. We are dealing with non-transitive routing. Non-transitive routing does not allow communication. If any of you guys took my BGP thing, what do we do in BGP to get past non-transitive routing? In BGP, we have this cool concept of a route reflector. What is a route reflector? Because guess what? Everything we do in the cloud is 30-year-old tech coming from networking. And I love that because I'm a networking person. And I love the cloud too because it's so darn agile. But no communication. That's what non-transitive means. So now, let's say we're dealing with BGP peering because this is going to be the solution. What if on VPC-A, let's pretend this was BGP, we could make it a route reflector. What is a route reflector? A route reflector breaks the rules of BGP peering that says, for IBGP, which is not transitive, break the rules. So take the routes, learn from VPC-B, give them to VPC-D, C, D, E, F, and G. And then take the routes of VPC-C and give them to VPC-D, E, F, G, and B. And so on and so forth. So everybody knows everybody's routing information. And if you do that with a route reflector, everybody can reach everybody, and then you've got full communication. With AWS, they give you an option. They've got two ways to fix this. They've got their own route reflector-like equivalent. It's called Cloud Hub or Transit Gateway. One of the same, there's a slight difference between them. It is identical technology. There is a slight difference in the implementation, and we'll talk about it. But Cloud Hub Transit Gateway is basically just a BGP route reflector for VPC peering. Again, 30-year-old tech, learn the network, learn the data center, and you will always know the cloud. Nothing's new. Each day, the cloud is a new feature that equals a network and data center feature from the last couple of decades. This is really exciting because it means the cloud is getting as good as the network and the data center soon. And it means if we can do better, faster, and cheaper, outsourced than we could do on our own, it's legendary, it's life-changing for business and tech. So it's wonderful. So with each one of these new features, if you understand the legacy, you will always, always, always know what to do. So we have two options. We use something like Cloud Hub or Transit Gateway, or we fully mesh them, meaning everybody's connected to everybody. In this full mesh environment, can B talk to A? Yep. Can B talk to C? Yep. Can C talk to B? Yep. Can C talk to A? Yep. All because they are all fully meshed. But n times n minus 1 divided by 2. 100 times 99 divided by 2 is a big number. It was a far bigger number than just, it gave us 4,950 peering connections. And I'm not Mr. Math. So look at it that way. So let's go and talk about Cloud Hub. And we'll talk about Transit Gateway too, because it's pretty much two sides of the same coin, different brand names and slightly different features. So what is Cloud Hub? Cloud Hub enables you to connect to multiple remote sites or offices that are their own VPCs in a hub and spoke environment and share routing. How are you going to share the routing? With my favorite routing protocol, eBGP. So we're going to be using BGP. So basically what we're creating this route reflector-like environment, but we're using eBGP versus IBGP. And here's what it's going to look like. It's going to be our workaround to the fully mesh requirement. So going over here, here's what you can see. Let's say we've got a Boston connection, a Washington, D.C. connection, and a San Francisco connection. And we want them all to communicate to each other. We enable Cloud Hub, and with Cloud Hub, we're exchanging routes with Cloud Hub via eBGP, and eBGP is transitive by nature, whereas iBGP is not transitive unless you enable the route reflection functionality. That is how it works. When do you use Cloud Hub? When you have VPN connections from your sites. Cloud Hub is for VPNs. That's how you separate Cloud Hub from Transit Gateway. They functionally do the same thing. Cloud Hub is for VPN. So if you want to know what AWS Cloud Hub is, it is for VPNs to break the rules of non-transitive routing. That's it. So Cloud Hub enables these hub and spoke transitive connections. It uses BGP for the routing information. Every VPC creates an eBGP connection to what's going on. And because it's eBGP, which is transitive, all the routes are sent. Now, you can basically create a policy with BGP and filter routes if you want to control reachability, but by default, eBGP, simple, elegant, and effective. Now let's give you one more example of what this looks like. Here you go. We've included some BGP. In this case, we're dealing with Sydney, London, and New York. You can see what we're doing here. We're running eBGP 64513. Is it an autonomous system number? 64. I think it says 001. It's hard for me to see. So the point is eBGP connections and routing. Now, this is for VPNs. What if we wanted to use a direct connection instead of a VPN? What if we wanted to use a direct connection and a VPN? Then we can't use Cloud Hub. Why can't we use Cloud Hub? Cloud Hub's only for VPNs. So AWS has Cloud Hub number 2. They call it Transit Gateway. Transit Gateway basically is the same thing. It enables you to create eBGP connections to make VPC peering transitive versus non-transitive in a hub and spoke environment. But Transit Gateway lets you use VPNs and private connections, so it's newer, it's more modern. Now let's talk a little bit about access control lists. Alonzo made an access control list with you earlier today. I think he made some security groups with you as well. But let's go back to those network ACLs. What is a network ACL? Quite simply, it's basically the same kind of access control list that existed on routers for the last 3 decades. An access control list or a network access control list is something that you use to keep unwanted traffic out of a subnet. So security groups keep traffic out of a host. Network ACLs keep traffic out of a subnet. I gotta tell you, this is one of the most confusing areas for students. Network ACLs keep traffic out of a subnet, and a security group keeps traffic out of a host. Excuse me. You will see probably 8 questions on the AWS Certified Solution Architect Associate 2022 version of the exam. Why? Because it's common and most people don't get it. Network ACLs protect the subnet, security groups protect the host. So a network ACL enables you to create a policy to allow or deny traffic. And network ACL is identical to the access control list that you can put on a router. If you're familiar with Cisco routing, they're just like an extended access list. You can specify the source and destination, protocol, and port number. Now remember, firewalls are stateful. They keep track of what's going on. So they know if you have traffic that egresses a firewall to allow it back in. Network ACLs are stateless. They don't pay attention to what's going on in your systems. And I'll discuss stateful much more when we deal with security groups. But network ACLs don't keep track. Once the packet goes through the access control list, it's forgotten about. So because network ACLs are stateless, you must configure them in both directions. Stateful and stateless do not mean whether you configure them in which directions. Stateful means tracking. Network ACLs are stateless. I will give you the example. A firewall is stateful. Let's pretend my left hand is a firewall. If I'm behind, if you're outside trying to come into my house and you're trying to bypass my firewall, you're going to be blocked, 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 blocked. You're not allowing in. If I I'm sitting here right behind the firewall, here's my firewall, and I want to go to www.gocloudcareers.com, I'm going to go out my router through my firewall to the internet. I'm going to go to the server, www.gocloudcareers.com, My traffic's going to come back. My server's going to give me a response. The message, the packet's going to come to my firewall. The firewall is going to say, okay, Mike Gibbs initiated this session sitting from behind the firewall. I allowed his traffic to the internet. This traffic is destined to Mike Gibbs' computer. Mike Gibbs originated the connection. I'm watching the connection because I'm stateful. Let it back in. So stateful really refers to monitoring of the connection. It's what's going on. So the reason stateful things don't need to be applied in both directions is it knows. So when you're dealing with a security group, which we'll talk about soon, which is stateful, it knows that if the message goes into the web server because you allowed it, allow it back out because it's traffic that was initiated in the right direction. So network ACLs are stateless. They keep unwanted traffic out of a subnet. So you have to configure them. Now, when you configure a network ACL, the order matters real badly. If you get the order wrong, bad things will happen. I promise you, every one of us that's been in networking or security for more than a week has misconfigured an access control list many times in their life, or at least once. I've done it twice. And I can remember each time it wasn't good. I locked myself out of the routers both times.
Just so you know, Alonso is kind of cackling off camera when you said that.
Yeah, I did it more than a few times. So yeah.
Yeah.
Well, I've done it twice, and let me tell you, if you're, SSHing into a router, one of the core routers for one of the world's largest internet service provider, and you slap on an ACL because they're in the middle of a DDoS attack and you accidentally block your traffic, you can't even get back into the router to go fix it. So anybody that's ever locked themselves by making an ACL mistake is just lying to you. We've all done it.
Yeah, and definitely just to kind of like really break it down for everyone, it's like having your home fortified and you lock the door, but you take your keys, throw them back in the house, and close the door behind you. So that's pretty much equivalent. So you're locking yourself out. So it's just really important that you understand the pecking order of the inbound rules.
Exactly, and that's the other reason I love you to have that backdoor network connections the way we described it, not the bastion way, through that direct connection or through that VPN, because this way when it breaks, you usually have an alternative back in, because trust me, you will break something. It's just a matter of when. So because access rule lists are processed in order, if you get the order wrong, you will break everything. So I'm going to show you what not to do. So if your first rule is deny everything, and the next rule is allow web traffic or port 80 traffic, let's really think about what happened. Packet hits the ACL, deny, trashed. An ACL, deny, trash, deny, trash, deny, trash, deny, trash. Now, if you wanted it to hit that web server, it's not going to happen because the access controller sees the packet, throws it away, sees the next packet, throws it away. The rule is deny all traffic. So if you deny all traffic inbound and all traffic outbound, you've got nothing. So you've got to change the order. Now, realistically speaking, you don't even need, as a rule, to do permits. Just do permits and the denies are implicit. So now let's look how to do it the right way. Rule 110, allow TCP port 80 from any source. Allow PCP port 80 from any destination. Look at it this way. You're saying allow web stuff in and nothing else. So now the only thing to hit. So when you write access control lists, two pieces of advice. They're processed in order. Do not make them 1, 2, 3, 4, 5. It's a rookie mistake I made 25 years ago, and never ever do this. Here is what's going to happen. What access control list you think you need today, tomorrow you're going to find somebody's PC gets worm infected and you need to add a rule, temporary access control list rule. You're going to find some new applications have been. You're going to find your ACLs, which you thought were going to be 2 lines long, which are now 39 lines or 300 lines long. So, technique, 100, 110, 120, 130, 140, 150. Give yourself 10 rules in between every rule. And that way, when you have to add rules, you'll have space because the order matters. So you may have to deny one host from a subnet and then permit the rest of the subnet. You have to do the permit, the deny, but so you've got to get the order right. So please understand that. Now, I want you to really architecturally look at this because a lot of people do not get this. Let's look at network ACLs. Network ACLs keep traffic out of a subnet. And a security group keeps traffic out of a host. So let's look at it this way. You've got your internet gateways, you've got your routers behind the firewalls and things which we're not showing. You're going to use a network ACL to protect the subnet and keep bad traffic out of the subnet, and then you'll use a security group for the host. So if someone asks you which you're going to use, a network ACL or a security group, the answer is both. Even the two of them together is not enough. You're still going to need firewalls and IDS, IPS systems. You're going to need so much more. So network ACLs protect a subnet. Security groups protect the host. So what we'll do is we'll talk about security groups. Then we'll go through some questions and answers. And then tomorrow we'll get into some fun stuff related to network performance optimizations and placement group. We'll get into Route 53. We'll get deep into load balancers. We're going to get into all kinds of cool, fun performance tuning. But we've got to get here. So now you know what the ACL does. It protects a subnet, and a security group protects a host. So now let's think about a security group, because they're a little different. A security group is just like an ACL, but it's applied to a competing instance versus a subnet. So the network ACL protects your subnets. And yes, I've mentioned this 30 times. No, I'm not normally this repetitive. But I got to tell you, after coaching students cloud computing for as long as I can remember, students get this wrong, and you're my students now, and I want you to get it right. So security groups are like a host-based firewall. They are stateful. They protect traffic getting into the server. So if my hand is the server and there's a security group and traffic tries to come in, it's only going to be allowed through the security group to reach the server if it meets policy. Otherwise, it is blocked. It protects the server. A good environment will have security groups and network ACLs. Security groups are stateful. Security groups support allow rules only. So all non-allowed traffic is denied. Only permit through the security group what you desire. So security groups are stateful, which means they track, they know, they watch, they monitor, they know everything that's going on with your connections. That's what security groups do. So that's where they get shared and do. So stateful access control lists are used. The stateful security groups are like stateful firewalls that get applied to the host. So you only have to apply them in one direction because they're stateful, meaning they track the connection. Architecturally, I'll show you. Here's what we've got: our internet stuff. We've got our network ACLs protecting the subnet. It's in gray now. Before it was blue. Now we've got the security groups that protect the host. So now you know what security groups do. Now I'm sure we've been at it for a couple hours. I'm sure you've got some questions for Alonzo. You've got some questions for me. So let's kind of answer as many questions as we can for you. Chris, do you have any questions that you can bring up and bring on screen, or did we not get that not resolved yet?
There were some questions, but they got some pretty solid answers in the chat box. Kind of surprised. I've actually learned something, so I can tell when they got the right answer.
Okay, so let's
so let me pull up some of the ones that did not get answered.
And actually, I'm trying to find the questions that were answered so I can know that they were answered correctly.
Okay, and also
unless Alonzo answered it.
And also, you also answered them after they got after they.
So I may have answered most of them. Some of our students may have also answered them. I just want to know.
Okay, here we go. Here's one, but no, that one was from your walkthrough. Never mind, your whiteboard. Sorry, that one was a long session, so I have to scroll back a while.
The question is, could you put a Bastion host behind those security controls? You could, and if you did that, it would be a whole lot less risky, so it wouldn't be terrible. The kind of security controls I'm talking about are going to get really expensive to really lock down your system. So here's your options. You could use a VPN concentrator. Well, if you normally speaking, you'd have a direct connection, so there's no reason to use the Bastion host. You've got a connection anyway. The Bastion host is only if you got there. So you would never need to use a Bastion host if you have a direct connection or a VPN backup, because you wouldn't need it. Is it possible to create a Bastion host that's secure? Sure. If you've got the skill to basically take a Linux kernel, just the kernel, and add the 2 or 3 packages that are necessary for a Bastion host, by adding packages and build your own Linux instance. And then you knew how to harden all the Linux files on there. And you made certain that no ports were listening that were not there. And then you really locked it down and put the best host-based firewall on it, the best anti-malware protection. And you really put 200, 300, 400 man hours into building this and make it secure. You could use a Bastion host. Realize when you're dealing with these kind of security apparatuses that are used for Bastion host purposes made by a Cisco, you're probably dealing with about $500 million just going into making these systems locked down and secure. Compare that to a Bastion host that's typically done by some person that they can do in about 5 minutes, compared to someone that spent $500 million hardening a host. So which one do you really want to use for your enterprise? I would not use a Bastion host for any circumstances whatsoever. And if I was going to use a Bastion host, which there's no reason to because you can use your private connections, I would make sure that I hired a company like a Zscaler, somebody that really is good in security. I would pay them to build me the best Bastion host. It would be a couple $1 million to get it right. And I would make sure they build me this system. They'd install all the right appliances, all the right software. They lock it down. It's going to cost a lot of money to do this right, to use Bastion host. There's no reason to ever use a Bastion host if you've got a VPN connection to the cloud. They do this in lab courses because if you don't have a VPN to the cloud, how would you SSH into your systems? But in reality, you will never ever need to do this. So Leo says, to have a Bastion host, you need 2 network adapters. What is needed for an iSeek tech tunnel? Nothing. Your data center is going to be connected to the cloud with a router. So basically speaking, you're just going to create your VPN connection to the cloud. Now, how are you going to get your data to the cloud anyway? You're going to send it over your direct connections. How are you going to keep your data sane or synchronized with the cloud? Over your VPN and your direct connections. How do you access the systems that are on the cloud? Over your VPN and your direct connections. So there's no point, if you're an enterprise connecting to the cloud, to ever think about a Bastion host in the first place. It's only useful in the lab environment if you don't have access to your subnets via VPNs or direct connections. Io, what's the difference between VPC peering and transit gateway? Great question, although we probably covered it in depth. VPC peering is when you connect multiple VPCs together. VPC peering is not transitive. So if you've got 3 VPCs, each one needs to connect to everybody. If you've got 4 VPCs, each one needs to connect to everybody. So it puts you in this n times n minus 1 divided by 2 situation, where if you've got 100 VPCs that need to peer, you would realistically need, I think it was 4,950 connections. Yes, that's what it was when we did the math. Whereas if you use Transit Gateway or Cloud Hub, you could basically have a hub and spoke environment and just peer with 125, with 100 of them and do 100 connections versus 4,950. That's the difference. Transit Gateway is just a way, like Cloud Hub, to break the rules of non-transitive routing with regards to VPC peering. Is there any others, Chris?
Yes, it's on the screen.
What's the difference between VPC peering and an endpoint? Good question. VPC peering is when you connect 2 VPCs. An endpoint is just to connect to a secure external service. So there's 2 kinds of endpoints. There's a gateway endpoint, which is used to connect to things like DynamoDB and S3. And there is an interface endpoint, which is used to connect to a service or other VPCs. VPC peering, by comparison, you take 2 VPCs and you completely connect them and they have access to everything. Connecting 2 VPCs with a VPC endpoint, specifically an interface endpoint that uses the private link, enables access to a single service and a single service only across your VPC peering. Chris, you can bring up the next one.
I'm going to bring this one up, but I think you just covered it. Like literally just covered it.
Okay.
Can you see it?
VPC peering and like, can I add more light to it, please? I think I just covered that.
Yeah, I'm just bringing it up because it's there.
I'm glad you are. I want to make sure we address everything.
Not sure exactly what this one is in reference to.
All I see is the same VPC peering one.
It says, is it similar to Cisco's hub and spoke DMVPN, but using eBGP?
Very similar. In fact, what he's actually referring to is Cisco's got, especially Meraki, They basically have this, auto create your VPN. They basically create a VPN. You've got your host that connects to your VPN concentrator or your firewall. And what happens is that adds routes, establishes the connection, and it puts you into BGP. So the rest of the network actually knows your IP address. Cloud Hub and Spoke is like the Cisco one. Here's the thing. The Cisco one is designed for remote access employees. This Cisco one uses IPsec encryption over the public internet. This Cisco one is entirely secure, extremely robust, and gives you much more control of the routing. So the Cisco solution gives you much, much, much more control, much more routing, much more filtering. And that's the thing which we don't really talk about a lot of times when we're talking about these certification courses. When it comes to security, if it matters, chances are you're going to go to the marketplace and get something from Cisco or Palo Alto or Fortinet or Checkpoint, because you're really going to need enterprise-grade security, which often is going to be much more than WAF or Shield or the cloud-native services. The cloud-native services are excellent, but sometimes you need more. And when you're dealing with 50,000, 100,000 remote access employees, you're not going to be using Cloud Hub. You're going to be using something much more serious. And the DVPN that uses BGP, eBGP with Cisco, is the perfect, elegant example of how you deal with a large number of people coming in remotely. Exactly.
All right. And are you looking at the StreamYard window or the YouTube window?
I'm looking at the YouTube window.
That's why you're delayed on me.
And that's why I'm delayed on you.
All right.
I haven't been able to. Oh, wait, I found it. Now I see the StreamYard window. Hand of God. Security is used at the instance level, and NACL is used at the subnet level. Exactly. NACL is basically, look at everything, protecting the subnet. But inbound and outgoing, you have to do because there's no state. Because it's not keeping track of what's going on, you have no choice. If it kept track like a firewall, you wouldn't have to worry about it. There you go, CEO Trials. SG is stateful like a firewall. Now, network ACL is not like an access control list on a router. Exactly.
One of the things that's really cool about AWS on the console is that when you're setting your security groups on the VPC and the management console, with the security group, you only have to add it once for incoming because it is stateful on the security group, and it'll reflect on outgoing as well. Just a little tidbit for you.
That is a really great perspective. Well, I'd say hand of God, a security group is, that's more IAM. It's grant access if access is granted. Security groups are basically if your packets meet a certain state, certain source, certain destination will allow in. Grant access is more of identity and access management, which is who are you? What are you allowed to do? Access granted or access denied? And then tracking what you actually did. We used to give it a much better name, authentication, authorization, and accounting. Authentication means who are you? Authorization was what are you allowed to do, and accounting was what you did. Somewhere along the name of coming up with all these cool terms that are really complicated to understand, we came up with this term identity and access management, which again is a fancy way of saying authenticate, authorize, account. Chris, you can bring up the next one if there's more. Yogesh. In FTP, the data connection ports are open dynamically. How can a NACL handle this? Well, they are and they're not. So what has to happen is when you're dealing with FTP, you're dealing with port 20 or port 21, and you only have to allow that. It's any source to any destination. Now, the responding ports aren't really the issue because you're going to say source port 20 or 21, destination can be any address, any port. So you don't have to worry about those ephemeral ports that are coming in that are dynamic on the way out. It always comes in at port 80 for www. It always comes in at port 443 for SSH, or I'm sorry, SSL traffic. Now what goes out, the source port will be different, but the destination port will be the same. Or in this case, the source port, if you're coming into an FTP server, the destination port, I think it's port 2021. I'm drawing a blank right now. I know it's either port 20 or port 21. So it'll be destination port 2021. Now, when it leaves the server, the source address is going to be coming from that port 20. The destination address will be something, the destination port will be something else, which is dynamic. So you don't have to worry about the destination, only the source, so we don't have a problem. Just enable it in both directions, and you'll be good to go. Chris, are there any others?
Yes, there are. Just a second.
Awesome. Actually, while we're waiting for Chris to bring some questions, if you're enjoying this content, please leave a like. Please type cloud hired so we know that you're here paying attention while Chris actually comes up with new questions. Okay.
There you go, Mike.
I have some cloud basics, but I really want to be your student, and I would like to talk to someone in your team first. Love to speak with you. Give our office a call. I'm actually going to put our office phone number here. I actually will have a phone. I will be holding the company phone today if you desire to speak with me. All the executives from my companies, we take turns sharing the phone, but I will have this phone today and I will have this phone tomorrow. So I just popped my phone number in the chat box. We'd love to speak with you. And yes, Jesse, we're happy to have Chris get technical. Let's face it, Chris is a little bit more technical than he'll let on. Chris is a heavy operations expert, heavy, with such extreme experience that when he came to learn cloud architecture from us, I was like, no, you're working for me. You're my new chief operating officer. You're an expert in operations. Chris also went to this massively long data science boot camp, which he won't really talk about because he'll tell you he's a guy. And Chris is muting my mic.
Yeah, I'm muted.
He's not wanting to say this because he's a shy guy. But Jesse, heck yes, Chris can get technical if he wants to. He, like me, pretends that he doesn't know how. You know how I advanced in architecture? And when I was an engineer, how does that work, Mike? I don't know. Let me get you an engineer. How does that work, Mike? You know, I don't know. Next thing I realized, I'm wearing suits. I'm now an architect, and the engineers are teaching me how to do things that I already knew how to do. But, you know, you got to do what you need to change your brand sometime. Mike, can you please explain VPC endpoints again within an architecture? Killian, absolutely. Here's the thing. Let's say that I wanted to connect to S3. S3 is an external service. I have two ways that I can do this, Killian. I can go out to the internet, across the internet, and back into Amazon and into S3. I could do that, right? So why would I not want to do that? I'm going to go to the internet. The internet traffic is not guaranteed. So I'm going to send my internet on the cloud. I'm going to go pay to send my traffic to the internet. And then it's going to come back in and I'm going to get bad performance. An endpoint is basically a way to create a private line that uses the AWS backbone to get your data from point A to point B. So an endpoint is exclusively just a way to connect on the AWS network. So think of an endpoint as basically as if they're going to create a fake wire for you across the network and route your traffic logically, privately, and securely on the AWS network. So you've got two options when you're dealing with connections. You can basically buy a wire with something that's called a private line or a direct connection. If you weren't using VPC endpoints and you wanted to connect two entities, you could just buy a private line between them and it would work perfectly. We've done it for the last 50 years. Outside of that, for example, you could go across the internet in like an IPsec encrypted tunnel, but again, internet bandwidth is not guaranteed. Or AWS gives you the opportunity to connect directly over their network with something called an endpoint. So an endpoint provides secure and high performance connections to an external service over the AWS network. I hope I answered your question. If you desire more, Killian, please feel free to ask again. Yogesh, we already talked about it. Comes in a certain port. You only have to allow that port. You allow that same port on the way out. We've been doing it with routers forever. We enable port 20 and port 2021. Or it's either 20 or 21. MW, so with the network ACL, you must think of all possible traffic scenarios. Well, you need to think about everything that you want to go in and everything that you don't want to be blocked. You must be careful about what you let in and what you get blocked. So the answer to that is yes. But you're only doing permits as a rule. So if it's a network ACL and you know what's going on, and all you need to do is permit to a web server, permit to a file server, permit to these things, you already know the protocols and ports. So anytime you're dealing with security, you must know your workflows. But guess what? Anytime you're designing an architecture, you need to know your workflows. You need to know all parts of architectures are looking at the business. What is your current state? Desired future state. What problem you're solving will drive the technology. The kind of challenge the company has determines what you need. What applications need to talk to what applications? That's part of your design. What people need to talk to what people, which is part of your design. Which parts of the organization need access to which parts of the network and which parts of the information? That's also part of your need. Who needs to access what? What do administrators need to do versus non-administrators? What do managers need to know? What is the minimum level of access you can give someone to do their job? That's what you need to know. In the military, it's called need to know. If you don't need to know, you're not given that information. In this world, we call it the principle of least privilege. I still call it need to know because it's logical and I understand what it is. I'm a person of plain, simple language. I understand what it is. What's this? It's a water bottle, very simply. It's not a device to carry water and distribute water at a controlled pace through a proper spout. I mean, I could call it that if I wanted to, but to me, it's a water bottle. So, I feel like it's easier. So part of architecture is understanding all parts of the business, all parts of communication, and all of the traffic flows between users. So please, 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 always think of all traffic scenarios prior to doing anything, because that's what we architects do. Wow, that's perfect, Jesse, a hydration load balancer. And when we're dealing with cloud computing, that's what we're seeing. By the time we're done looking at things, you don't even know what they are with all these cool naming conventions. So exactly, a hydration load balancer.
All right, I put the next question up there.
VPC peering, can it be likened to VRF leaking? Well, it's kind of interesting. For those of you that are not familiar, about 20 years ago, we had an RFC 2547, which specified BGP VPNs. And what happened was in this cloud, the organization would have an MPLS. They would basically have like an OSPF or ISIS layer 1 network, a flat network, which would be the IGP. And then they would turn on RSVP, which would enable us to determine if a path was there. And then we would turn on either the label switching or tag switching. And then we would overlay BGP and we would create a VPN. And then what we ultimately did was created virtualized VPN instances into the router. So the routers would take multiple customers and they would put them into VRFs. And realistically speaking, everything was logically separated all across the common network. So you can think of cloud computing as the same thing as VRFs and BGP VPNs. It was a cloud then and it's still a cloud now. VPC peering or enabling two entities to communicate across your private network while being logically isolated and separated from each other is exactly like virtual routing and forwarding instances that were part of that BGP 2540, RFC 2547 VPN of about 1999 and 2000 when I did my CCI exams. Yes, absolutely. In a lot of ways, they're very similar, although they have their differences. Alonzo, why do we have to have all the ports outbound of a security group?
Why do we have to have 1024, 625 in the outbound of the security group? Well, what we're doing is that 10.0.0, that default, is that's going to be your avenue to come out of your subnet, out of your VPC into the internet. So the 10.24.625, I wasn't sure if I saw that, but
yeah, what Alonzo did was he basically, since he wasn't thinking about exactly which port the traffic was going to come out of, he enabled everything that would possibly pop up. Guaranteed it would work. So I know what you did there. I wasn't watching what you did.
Okay.
And then I was thinking, well, yeah, that'll work.
Okay. That's where it goes right back to the knackles and everyone making a mistake every now and again. This is a perfect example.
So that was something that was specific to
Mario Millen. You're one of my students.
You caught me, man. I appreciate it.
I know you, and you caught something really minor. Why did he do it? He wanted to be certain. Mario Millen, I know where you work. You and I have grown up in the same networking world, so good find. Thank you, Mario.
Good. I appreciate that.
NitroPan, can a network ACL log inbound, outbound requests? Well, sort of, but on the router, you've got better logging with regards to syslog. What you would do here in NitroPan is what you would do is you enable VPC flow logs. And VPC flow logs are really cool. They're just like Cisco NetFlow, where they can show you the source, the destination, and the protocol and the flow of your traffic. They will show you which things get blocked by network ACLs. It will show you which things get blocked with security groups. It will give you really cool data. And I got to tell you, VPC flow logs are really cool to me because I'm an architect. And as an architect, specifically on the cloud infrastructure side, I'm always thinking about the data that's traversing the system, the infrastructure. And you'll get great information from VPC flow logs. Lots of times, I make a point of saying, where's these crazy names? And part of it's for fun, but part of it's seriousness we need to know. But VPC flow logs are really awesome. It's like getting NetFlow in the cloud.
So the next question is born out of a conversation that was had because the Slack community was brought up in the chat box.
Okay.
So Jay Terrell decided he was going to ask this for the other people that didn't know what was going on.
Hey, Mike, how can I get, again, now asking for those in the chat that are not part of Go Cloud Architects?
Yeah, because we started getting questions about the Slack community, et cetera, in the chat box.
Okay,
so like this one.
Okay, so the key is students that are on our program can join our private Slack. We are not like there's a course provider that has a Slack channel that invites everybody to Slack, and then as soon as somebody asks them a question about getting hired, this person blocks their notifications so they don't have to hear from you. We are not like that. I've got lots of students that have made that complaint. That is not us. We have a very busy Slack channel for our internal students. Our students come in, and when our students come in, they talk to each other. And when our students talk, and a lot of my people have complained about and experienced about it, that's how we know so much about the situation, because we take in those people and we train them all day. So our Slack channel, for example, has hundreds of messages per day. Our students are turning in video assignments. They're turning in, interview practice things. They're turning in architecture designs. They're turning in career plans. They're turning in resumes. I am like the busiest person in the world, literally grading and providing feedback on students' homework assignments. I think I spend 2 hours per day going through assignments. So our Slack channel is really big. We basically have a $25,000 cloud computing program that we offer for less than $1,000. That Slack channel is included as part of it. We also include live training where we do live classes, live architectural training classes twice per week, and we have a Slack channel. So that Slack channel is exclusively for our students. For example, if you'd still like access to information that is outside of our program, we do the best we can to provide as much free content as we can on LinkedIn. Chris, please post a link to our LinkedIn channel. Also, I would say to you guys, we all need more. Tech training is so critical to everyone that we have. Our future completely is 100% with regards to you guys. People like me, for example, have been involved in technology for decades. We already know the job. We don't need training. We need to teach you guys to be the new generation of technology leaders. Every one of you has the ability to be technology leaders. Now, I can tell you personally, do you know why I do all this free training? I do all this free training for the following reason, and it's really important to me. I know what it takes to get hired, and I know what's out there isn't enough. In fact, today I made a social media post. I'm going to share it with you guys if you guys want to look at it or comment on it. I made it on LinkedIn. I'm going to provide the link. To me, it's really important that we all demand our course providers to be experts in what they teach. A few weeks ago, someone asked me to teach a 4-hour CCIE program, and they offered me an amount of money that was just so high. And I was like, are you kidding? I could do this in 400 hours, but not 4 hours. So here's the thing. I really, really want you to demand from your cloud providers. Tell them, if you've never worked in networking, don't make an advanced networking course. You need to hear from experts. I don't talk about coding. Why? I'm not a coder. I teach what I know. And I think we all demand our instructors teach what they know. Because if I go to training, I'm expected to learn something. I need to be better. Yeah, someone want me to do a 4-hour CCIE training. And what's worse, They were a very prominent, very preeminent ed tech company, one that everybody knows by name without even thinking about it. So the point is, I want you guys to be out there. Ask for more. Demand more. If we need more, I'll do as much free training as I can. Next month, we're going to try and do a CCNA course. You guys ask for it today, we'll do some free subnet training. So we'll give you as much as we can for free. But things like Slack, things like our interview training, things like our executive communication training, we've got to give our internal students a competitive advantage to be the best in the world so they get hired every time they get interviewed. So that's really critical to us that we do that. So we give you guys as much as we can for free, but things like our Slack channel that are used for private and executive communication between our executives and our students and our instructors and our students, we have to keep that private. But we keep our training as affordable as possible. So it's in within budget for anyone, anywhere in the world. Who has the next?
Yeah, since you just went into that, I'm going to post a link to the enrollment page while you answer the next question.
Okay, great. I love answering questions and I love teaching. There's no more fun.
It's a two-parter.
Our endpoints and additional pay for connection services, Derek, everything on the cloud is an additional charge. Everything on the cloud is an additional charge. Normally, you pay for a network connection. On the cloud, you pay for the network connection, you pay to each day to have the connection, and then you actually pay to use the connection. So even though it's internal, you're still going to have to pay for it because you're technically going outside of your VPC.
There's another one, but there's more. But I'm getting to the section where you asked them to type cloud hired. So give me a second.
Oh, cool. I love to see interactivity because that way I know people are alive and awake. Actually, if you're still here, type cloud hired, please. That way I know you're here.
Come on, Mike.
He is the king.
Seriously, Chris is
King
fantastic,
Chris.
actually.
See, this is what you get when you do that to me. I get all the praise.
Good. I wouldn't. This company wouldn't be half of what we are without you helping us.
There you go.
Try my
Thank
best.
you, thank you so much. I so appreciate your very nice, kind words.
There we go. That's the person that was asking about the.
Look forward to working with you.
I think when you're surrounded by really positive people in a great environment, this is where the magic happens.
Jeez, all these cloud hires.
Yeah, Chris, I asked for it.
Don't ask for it anymore.
We need to know people are here because I don't want to bore people to death. I want to know they're here. I want to know they're learning and having fun. We love this.
ICMP, are you there? Are you there?
There you go. There you go, Alonzo. High praise. That's the highest of praise right there.
Wow.
Do you see that, Mike?
Yeah, Mario, I think we can connect you to Alonzo. When the time is right, Mario, you reach out to me. I'll make the connection happen for you. You're one of our students. We worked with Alonzo to make him such a great cloud architect. Now he's so good, we use him for everything. So yes, I can make sure that we can connect those two things for you, Mario.
Well, just to let you all know, I've learned so much from Mike. So it's like, if you want to go straight to the pitcher instead of pouring it into the cup, Mike is the one. So I think he is a phenomenal teacher, and you're going to learn so much. And if there's anything I can do to help support that, I'm definitely here for you, for everyone in the community.
So
thank you so much, Alonzo.
There are currently no more questions.
Wow. Okay. Well, so let's talk about what we're going to talk about tomorrow. So tomorrow, here's what we're going to do. We're going to talk about network performance optimizations. We'll go into groups, which are really fun. We're going to have a great time with DNS. We'll probably get a little deeper into DNS than I'd like to, but we'll probably do it because it's important. We're going to talk about load balancers, which are one of my favorite things. But we'll get into much deeper internal load balancers, external load balancers, literally all kinds of stuff. And we'll begin getting into security. And when we get into security, we're going to get into security. We're going to go a lot deeper than traditional just AWS security, because I want you guys to all know. Did you know the cloud gets hacked every day, and 60% of all the hacks are related to misconfigured S3 buckets? So thank you so much. I'm just trying to do the best I can to try and help as many people as possible along the way. When I left medicine, I moved into tech, it was hard. So I don't want anybody to have that struggle.
So a couple of questions came in as soon as I said that there weren't any. So give me a second.
Questions are good. People are here and they have questions, we'll answer them. Don't forget, everyone, tomorrow I'm bringing those recruiters. So if getting cloud hired is part of your goals, please be here.
going to be awesome. If anyone was there for the last recruiter event, it was a very, very good opportunity to experience and see a lot of questions that people came out with. So don't miss this one.
Yeah, there's some really great people. To let you know, it's IT Excel. They will be taking your phone numbers, your resumes if you desire. They have placed more people that I've given them over the last 2 decades that I can count, and they're here for you too. So, can I give an example of both a NAT gateway and an internet gateway being used in the same VPC? Sure. Let's say you wanted to connect your web servers, and if we can do something about the spam that's coming in from somebody called webcabschat.com.
Sorry. That
Okay.
Oh, wow.
We don't want our students being subjected to that. We want to run a clean, classy operation and help our students. We don't need that around.
We don't.
So here's what you might do, Rohan Fernandez, because that is an exceptionally great question. Can I give an example? So an organization might have some web servers, and for the web servers, they might, or basically the front end of the web servers, the load balancer where they're at may need to be in viewable. So for example, you would use an internet gateway to make sure your internal systems that are in your demilitarized zone have access to the internet. Now, by comparison, you don't want your internal system reachable by the internet. So for example, because you don't want your systems that you have your internal systems reachable by the internet, what you could do is you could use a NAT gateway to enable your internal systems to go out and update their operating systems via patches, give users internet connectivity, but you don't want those users reachable. So in your VPC, you could have a NAT gateway for your internal users to be able to go out and maybe update their operating system. And you could additionally have an internet gateway that's used for your web servers and things like that. Hope I answered your question there, Rohan. Chris, you can bring up the next one.
Okay, here we go.
Here you go. Hi, Alonzo. You created a virtual machine and an EBS and tried to attach the EBS to the VM, but snapshots lifecycle policy was required. How can you do that?
Well, you shouldn't have needed a snapshot lifecycle policy. That shouldn't have been relevant. What you should only been able to do is just create that EBS, and then you were able to attach it to that EC2. But I'm more than happy to go over some of the concepts with you at a later time if you'd like, Julie.
Anthony, you've been a Unix admin for a long time. Fantastic. I've been playing with Linux and Unix for 2.5 decades now. Now you want to go to solution architect. Can you make the transition? Absolutely. So Anthony, when I get questions like this, here's what I want to let you know. I went from medicine to lead architect within 6 months. I have worked with people, literally speaking, from customer service, from sales to graphics to anything, and it's easy to get them ready to be a cloud architect. Now, generally speaking, for me, it takes me 8 months of someone that's got no tech background to get them to the point where they're ready to be a cloud architect, and it takes me about 500 hours of training, and that to do so, and it takes the architect themselves, a good amount of studying, but they can do it with zero background, meaning somebody could have been selling cars last month, 8 months from now with the right training and the right effort. Now, the right training is 500 hours, and the right training is that student going and studying a lot every day. But that person can easily make the shift. People coming from a networking background, I know CCIEs like me that have gone straight to distinguished principal architect roles on the cloud with no background in the cloud at all, other than networking expertise, because the cloud is not new for us. We've been working on clouds for 30 years. So there's that. Linux admins are great. With a Linux admin, you typically know something about security, you know about users and groups, you know about the kernel, which is essential. You typically have some concept, a little bit of a routing table, not a lot, but still some. You understand how to lock down systems, disabling unnecessary services. You understand IP connectivity to some degree as a Linux admin. You're familiar with VI and all those other things that are there that are associated. So you know a lot about computers. Now you also understand how to write a basic shell script should you want to do some of those engineering things, but you really understand how it works. Now to also let you know, all these clouds are built on Linux, all of them. In fact, every one of my students in the Cloud Architect Career Development Program builds their own cloud. What do? They install on a bunch of Linux kernel. Then they install the cloud control plane software. Then they set up the data plane, the forwarding, and everything else. They set up the storage. So these are the kind of things that we actually do. So yes, a Linux background is excellent. In fact, I have a person from Red Hat that's creating a Linux for cloud engineering program with me for that same reason, because it's a very good skill. I am not a Linux engineer, so I don't make it, but we're collaborating with someone that's worked for Red Hat for the last few years, someone that I coached, someone that had no tech background that I coached that took a senior position at Red Hat, someone that took that position and worked at Red Hat for years, someone that just left Red Hat and went to Redis now, another great company, one of my students. And he said, Mike, how can I be part of bringing this to you? Because he's an OpenStack Ansible cloud expert and a Linux expert. So I said, hey, wait, let's make a Linux for cloud computing course together. So if he does what he's supposed to, we'll be filming it in 2 weeks. But, it's hard to develop on external course providers because they don't all work like 100 hours a week like me. Does ephemeral ports need to be open for outbound subnet? Generally not. But typically speaking, you can just specify the things that you need. Mfresh SA, are you in South Africa perchance? Thank you for the great session. Greetings from Johannesburg. Wonderful. So happy to hear from you. Abigail Marks, thank you. Chris, Mike, and Alonzo, you're the best teacher I've had in all my education. Thank you so much. 100% sincere. So happy I found your channel last week. So happy to hear from you, Abigail, and I look forward to speaking with you on Monday. Wise Geeps, hi chaps. Can I use these free sessions to pass the AWS Associate? Absolutely. So let me give you some guidance on passing the Associate exam. First, this course will get you there. Secondly, we have a completely free AWS Certified Solution Architect Associate ebook. If you would like more certification training, I strongly recommend Andrew Brown's free training on YouTube and Exam Pro. I've looked at every single course that's out there. Almost every one of those courses made me decide to do free training. But certification training and employment training are two different things. We focus on employment training. I will tell you, Andrew Brown's got a very good AWS Certified Solution Architect Associate course. I encourage you to read our book. I encourage you to complete our course. I encourage you to look at Andrew Brown's, which is more certification oriented, and poof, you will have the simplest time ever. Now, students tell me every day that they've used mine and just passed the course exclusively, but I am an over-preparer. I like to take in everything. So I will tell you, this, our AWS Advanced Networking, for example, and our Certified Solution Architect Professional, Andrew Brown's course, that'll give you all the certification materials you ever need. If you want to practice test, review, and prep, their CEO, Haman Sharma, is a great guy. I have no financial connections with him whatsoever, but I know him well. I know his other partners in that business, and they work really hard to deliver a good product, and they have a very good practice test for the Certified Solution Architect Associate. But yes, this is more than you need, but I've just given you a list of all the free resources that are out there. Our ebook, our course. Yogesh, I have to look up what you mean by QUIC. I've been an architect for too many years. There are 1,000,001 acronyms. So let me see if I can find this acronym that what you're a multi-coach transport over UDP. Hold on, let me tell you. Okay, so it's a little different. This is not something that I've ever worked with in networking in any way, shape, or form. Generally speaking, if I was going to try and create multiple connections and layers, I'd use something like port aggregation protocol. I would do it on the routing side. I have not seen anybody use this protocol in my experience, so I don't really want to comment. It's not something that I typically use, so can't answer that question. Okay, sometimes you get it confused between an elastic IP and an internet gateway. Great question. So an elastic IP is a public IP address, Nitropan. Internet gateway is a router that connects to the internet. Now, when you connect to the internet, the router that connects to the internet will need an external IP address or an EIP, elastic IP address. The way I remember what EIP is I remember external IP address, because the word elastic doesn't mean anything to me, unless you're talking about a rubber band. So, elastic doesn't mean anything to me. So when I think of EIP, I translate elastic IP address into external IP address, because that's what it really is. And then I always know what it is. So think of an EIP as an external IP address, except on the exam, remember it's called elastic because it's AWS. Just to slap elastic in front of everything, and it's probably your right answer. And an internet gateway is a router that connects to the internet. So I hope I can help you. Hope I helped you answer that question. Mike, when do I sleep? That is a really good question.
What's
not
that?
not as much as you would think, because I typically start my days off in India by speaking to folks in India or Asia. And then after that, I'm next speaking to really great folks in Nigeria, Cameroon, South Africa. That's typically next on my list. And then from there, I'm in Central Europe and I'm in England. And then we hit New York City. So New York wakes up, the East Coast wakes up, and then next Texas wakes up. And then after that, California and Oregon wakes up. So I get calls for all day, every day, 7 days a week. I don't know how I've done it, but it works this way. Nitropan, thank you so much. We want to do anything we can. And Jesse Murdoch's probably right. I don't get a lot of sleep. That's why
I think it's safe to say, yesterday we learned that Mike no longer reads 3 books a day or 3 books a week or whatever it was. And I'm pretty sure it's safe to say that Mike no longer sleeps either.
No.
I'm working on that. We got to get that taken care of at some point.
That's actually how I earn my paycheck.
Yeah.
By making him stop.
He's on an IV drip with coffee.
Actually, seriously, Chris is so essential. Chris will say, Mike, stop. And I'm like, what do you mean? I got a little work to do. And he's like, no. If you don't stop now, how are you going to, and you don't sleep for 1 hour, how are you going to be able to present and talk tomorrow? So Chris is really essential to my team, but I just hired 2 new people. I'm bringing in somebody from AWS to join my team. Someone that's a CCIE as well, and I'm really excited to be bringing them on. And I just hired a really young, really smart person that I plan on training a couple of years from now to being a key member of our team. So that's how I do it. So you have 3 years experience as a Linux admin. Great. How can you switch to AWS Solution Architect Roadmap? So let me give you a little piece of advice there. I don't recommend you become an AWS Solution Architect at all. I recommend you become a cloud architect, and I'll explain the difference. An AWS Solution Architect is someone that only knows AWS. Guess what? I recommend against this. And here's the reason. When it comes to driving a car, who would think that I'm going to learn Toyotas? And next week, you're going to take another certification to learn how to drive a Honda. And then the month after that, you're going to take a certification to learn to drive a Chevy. And a month after that, you need special training to drive a BMW. And then a Mercedes. This is crazy. Learn how to be a cloud architect, learn how to drive, and you can work on any cloud, anywhere, anytime. So first thing is I recommend learning the cloud. Note when we discuss things today, and I had to keep the certification related because we're online and it's public, but I kind of took away the certification terms. I kind of tried to get rid of words like elastic. I tried to call a virtual machine instead of an EC2 instance. I talked about object storage, block storage, and file storage. So, because of this, I always stay neutral to the technology. So, how do you become a cloud architect? Well, I'll give you the 2 ways. The easiest way is to take our Cloud Architect Career Development Program. It's cost effective. It's a process. We take people in, we take people out, and we get hired. Our students all leave with a certified solution architect professional, which is basic intro to cloud computing. Our students all have extreme cloud architect knowledge, communication skills, executive presence, emotional intelligence, and the design skills to be great. Our students even build their own clouds from scratch. That's how we teach cloud computing, as our students know the cloud. So there's that. So we'll keep going. Let me finish answering this, Chris, before we bring in the next one. So that's how we do it. If you're not with us, here's what you can do. You can read the Routing TCP/IP book from Bassam Halabi. You can read the 2 books from Jeff Doyle, Routing TCP/IP, Volume 1 and Volume 2. You can read the Stevens TCP/IP book. That will give you a basic intro to networking, and that's about 5,000 pages of reading, and it's about $200 a book, but it will help you get there. We teach all of that in our program. The next thing after that, you need to learn server virtualization. So get a VMware for about 1,000 pages, you can learn virtualization. Next, containers, because that's a computing thing. Go to VMware, go to Docker, go to Kubernetes, and about 1,000 pages you can learn containers. Next, firewalls. About 1,000 pages of documentation from Cisco, about 1,000 pages of documentation from Cisco, Fortinet, Checkpoint, Palo Alto. That'll give you some networking. That'll give you some security firewall knowledge. Do the same thing for intrusion detection, intrusion prevention systems. Now, learn Linux, Apache, MySQL, PHP. If you are not with us, get some Linux training. All of our students do a tremendous amount of labs on Linux, including building their own clouds. But you know what? If you're not with us, get some Linux training. Then make sure you learn how to build the LAMP stack. And then after that, what you need to do is as follows. Learn Active Directory, as well as radio server, because you must know enterprise-wide AM. Again, 1,000 pages of reading will take care of that. After that, you need to know the cloud. So build yourself an OpenStack Ansible cloud. Build yourself a Nutanix cloud. Build yourself an OpenStack Ansible cloud and a Nutanix cloud and connect them to each other. Build an OpenStack Ansible cloud and connect it to AWS. We cloud architects work on multiple clouds all day, every day. So do that. Then set up server virtualization, build containers, build firewalls, build VPN concentrators, do all this, build clouds. If you're not with me, you need a 16-core Xeon server with 128 gigs of RAM and 3 SSD drives and RAID 0 for these things. When you've done that, you got to remember, architect jobs are not just tech jobs. They are 50% tech and they are 50% leadership. If you're with us as part of our program, it is covered. If you're not with us, don't worry. You can take a Speak Easy class for 3 days. They call it Talk So People Listen. It's an intro to speeches. We go much deeper, but about $2,000 you can take that. If you are not with us, get some emotional intelligence training. Emotional intelligence training on average raises your salary $30,000 a year. So over the 30-year career, that's $1 million of extra training, extra earnings. Why is emotional intelligence so happy? It's the difference between getting hired and not getting hired when you lack experience. Emotional intelligence is going to be critical in the role of an architect. You're going to meet with the CEO and the CIO, and they've already spent $3 billion on technology, and it's not working. You're going to have to be really emotionally intelligent to work through them. You're going to have to learn executive communication skills, take a CXO relevancy training if you're not part of us. These are the skills. We are business executives. We are business leaders that are married, hybrid technology professionals. That's the skill. So learn how to present, learn how to write. As an architect, you will be spending 50% of your time presenting, writing, and selling, and 50% of your time designing. You will not be configuring. You will not be coding. All design, present, document, present, design. That is the job. That is the skill set. I'd be happy to get you there if you wanted to work with us. If not, I've told you exactly what you can do on your own. We're much cheaper, but in either case, you can get there. Any others, Chris?
Yeah.
What is an API? An application programming interface is a way that you can actually connect to something. So with an API, you can push new configurations to the routers. You can modify configurations, for example. You can do that. So these are the kind of things that you can do via an API. Any others, Chris? I know at some point we're going to...
I'm looking for questions related to the content, giving them priority. So give me just a second.
Did you see the hand of God's response?
Yes, I was
Yeah.
starting to type a response saying that I am from Philadelphia, though I consider myself to be Greek and speak Greek at home, and let's just say being Greek is a big part of my life. But other than that, no.
Okay, so I'm gonna roll all of these questions into one because I know how you're gonna answer it.
You mean, I'm going to give a very detailed answer. Thank you so much.
And they're all about the same thing.
Okay, good. You brought it into one.
So, okay, so we're going to start with, so let me read them all off. I am looking to enroll for the course. Can all the training go on simultaneously?
Yes. We've got lots of students that are our students taking a course. And
What do
doing
you
this.
think of a cloud architect job that job description that requires cloud engineer experience or DevOps experience?
No.
What is the difference between cloud practitioner and cloud admin? I have a practitioner certificate.
Okay.
And then I got 2 others to roll together after that.
Okay. Well, I will say the cloud practitioner is just a certification from AWS. The cloud practitioner was designed for salespeople to know enough to sell AWS services, not designed for technology professionals.
Then thoughts on cloud architect jobs that require engineering or DevOps experience, quote unquote, require.
So you really have to do this. So like we'll have the recruiters talk tomorrow. So what happens is when you see HR make a job description, what HR does is I'll give you the real secrets, the dirty little secrets of companies, because I've been at the elite levels of all of them. A low performance company like a cable company has 3,000 applications for a single job. And I don't think anybody out there would say my cable company is the most pleasant people to deal with. Best customer service, best performance, best experience. They get 3,000 applications for a single job. Now, a good company gets more than 5,000 applications for a single job. So what HR does is they create these absolutely stupid job descriptions that include Olympic gold medals, 30 years of Kubernetes experience, even though Kubernetes is only a couple of years old, experience as a cloud engineer, experience doing DevOps. And then here's what happens, because I spent lots of years, I've done 5,000 interviews in my career, so I've seen it. HR then sends you these people, they've got DevOps experience, great. They've got engineer experience, great. And when you ask them how to design something, they don't know. When you ask them how something works, they don't know. They've got great coding skills, but they don't know. We can't hire this. So what I do is I don't deal with HR when my students generally deal with HR. What I recommend doing is as follows. Reaching out to somebody in that company, if you know them. Reaching out to people that work there and say, hey, wait, this is the cloud architect job. What do you do? I can call 10 friends at Amazon and say, hey, you're an architect. What do you do? And they can say design, present, and sell. And I said, you configure? Of course not. Do you code? Of course not. What do you know of DevOps? Well, it's automation. We've got these people that do that. So there are some non-architect jobs that are engineering jobs that don't pay like architect jobs, that pay like engineering jobs that they call architect. I had one of them 30 years ago. I had worked for a South African company for about a week. The management was a little arrogant. I didn't enjoy working with them, so I just disappeared. I had 2 job offers at the time. And they made me a consulting systems architect. And I said, what's a consulting systems architect? And they said, a consulting systems engineer, but we want to give you a little better salary and we want it to sound cool. And I said, so what am I going to be? They said, a systems engineer. I said, then why am I an architect? They said, it sounds cool. So they said, do you know how much more we can bill out your services for as an architect than an engineer? I said, what? So they said, it's all about perception. So I left that company 3 days later. I literally walked out the back door. That company was a very good company. They were one of the largest gold partners for one of the biggest networking companies in the world. And they just got bought by one of the largest telcos in the world. But, you know, that wasn't me. If I'm an architect, I'm going to do architecture. If I'm an engineer, I'm going to do engineering. So the key is real architecture jobs, people don't do this. Now, they may say experience. And if you can actually call someone in that company, you're probably going to find out they don't actually want anything. What people do know is they would like to know that you are familiar with the DevOps pipeline, what it is. So you should know the CI/CD process. You should know what is a blue-green deployment and how they work. But that's all you need to know. So typically speaking, that's why we use recruiters, because they'll call the hiring manager and say, hey, what do you really want an architect? They're going to say a systems designer. And we're going to say, in the job description, it says DevOps. And they're going to be, oh, I don't need that. HR stuck that thing there. I only need this. I need someone that has expertise in network design or expertise in cloud security. Really, that's what's going on, is they're looking for specific areas of expertise. So don't worry about what's in the job description, worry about the hiring manager wants. And that's why we have 250 recruiters that we use to ask the hiring manager exactly what they want, so we can send our students to the hiring manager and skip HR. I've never had what was ever desired in the job description for any of the 5 jobs I've had in my career. It never mattered. I went straight to the hiring manager. Oracle Cloud is offering free training until December 3rd. What are my thoughts? Well, here's what I think. In general, education is a good thing. So I'll never say don't do training. Oracle is offering the training themselves, so it's by Oracle. So I promise you, it's going to be far better than anything you can find on Udemy, because it's going to be done by Oracle. So there's that. Oracle Cloud, I see growing a little bit, but again, I about learn the cloud and then be able to use it anywhere. So the question, Nitropan, is where is the best use of your time? So the average cloud architect earns $600 a day, average. A good one earns more than double that. So knowing that, where do you want to spend your time? If you could spend your time learning Oracle, that's one way. If instead you could be spending your time learning architecture, executive presence, communication skills, and how to be a great architect versus somebody else's cloud, the name of the service and how to configure it, it will probably help you be the best, be better at it than a career. So somebody recently said, Mike, I'm a certified solution architect professional and a CCIE. Do you think a master's degree in technology would help me? And I said, where's your current salary, where you're at? And I said, no. I said, but an MBA would. I said, business acumen training would. Executive presence training would. I said, the master's degree in tech can take you from 180 to 190. I said, but an MBA, business acumen, communication skills, emotional intelligence, executive presence can get you to 350 a year. I said, where do you want to maximize it? Where do you want your career to be? So for me, I would ask you, where do you desire to be? What job do you desire to be? If your job is desired to be an architect, if you don't have business acumen, if you don't have emotional intelligence, executive presence, and know what a CEO cares about, a CFO cares about, a CIO cares about, if you don't understand the network in the data center, that's the job. I'd invest my time in networking, data centers, and the finance. If you have a big background in those things, let's say you're an MBA. Let's say, for example, you're a network architect. Let's say you know all about networking and data centers and security and cloud, and you want to pick up the Oracle thing and it's free. I strongly encourage you to do that. So I think you need to look at where you're at and where you want to be. If your goal is just to be an architect, which is a great goal, it's what I've done for years, decades, and I love it, being an architect, I'd study architecture and all the things that go along with business leadership skills. If I wanted to just work on Oracle, or I was already an expert architect and I wanted to pick up the Oracle, then I would do the Oracle. So I hope I answered your question in a manner that makes sense for you.
And that's it.
Okay, that's it? That's all the questions I'm allowed to answer?
No, that's it. You did it.
I did it. I answered everybody's questions. So everybody, tomorrow morning, 9 a.m., IT Excel, and you can ask them any questions you want about stupid job descriptions and things like that. You can ask them any one of those questions. The question is a master's degree in cloud management. I will answer you that question personally when we speak, but I will tell you this. If you know what you're doing, an MBA will yield 3 times the results of a master's degree in technology. But if you just love starting technology and all you want to do is deep engineering, well, then the master's in technology could be good. So it depends.
And Nitropan asked, you still need certifications, right?
You still need certifications. Here's the thing with certifications. The certifications signal the hiring manager that they should interview you, which is great. But they don't signify that you're capable. So here's what's going to happen in an interview. I'm going to give you the honest, dirty little secrets. If you go on an interview, and when you go on the interview, and they interviewed you, they believe that you could do the job based upon what's on your resume. If you do well on the interview, you will get hired. If you don't do well on the interview, the hiring manager has 2 choices. You're terrible, you don't know anything, you can't communicate, and I don't like you. That's option 1 for the hiring manager. Option 2 for the hiring manager is, it was so nice to see you today. I really like you. Come back when you have some experience. Now, which sounds better? You stink, or I need more experience. Now, I'm exaggerating the concept just slightly, but it's kind of true. So don't let anybody tell you that you can't be something. People interview people without experience all the time. All the time. So be great at what you do, excellent at what you do, be a specialist, and you will get hired every time. We're getting cut off. So 9 a.m. Eastern time is 2 p.m. UK time, which makes it 3 p.m. Central European time for the time zones there. What about TOGAF? I think TOGAF is an excellent architecture certification. I would say a certified solution architect professional, maybe something from networking, and a TOGAF looks really, really great. Excellent question, Ned. And there. So yes, Jesse Murdoch, 9 a.m. Eastern is 6 a.m. Pacific. Good point. Amika, are there any limitations for a university dropout in a cloud architect careers? Absolutely. You can do anything you want. The secret in tech, no one cares your education. They care about your capability and your competency. So you can be there, no problem. You need to be great, great, great at what you do. To be a cloud architect, you will need several certifications, but it's not the certifications, it's the knowledge. The certifications that typically mean are you need one from a cloud provider. Typically speaking, you need a certified solution architect professional, an Azure expert, or a Google professional cloud architect. One of the three, and that's it. The rest of your training should be in networking and data centers because that's the cloud, or whatever specialty. So if you want to be a cloud security architect, get that Azure expert and a CISSP. You want to be a cloud network architect, get a CCNP, as well as a certified solution architect professional. It's about building a brand of expertise. That's what we're trying to do. Any other questions for me?
Nope, not yet.
Okay, well, my COO's internet is going to get cut off at 4 p.m. due to maintenance, which is in a few minutes. I've got a big day, lots of phone calls to return from people I've spoken to. Well, I got to tell you, I can really appreciate this. I can appreciate things coming in from Arabic, things coming in from Greece. I really love this, as well as Hebrew as well. I'm equally happy with several of those languages, hand to God. Really, really, really appreciate that. As Jesse has said, and for the last few, what about Aviatrix? Aviatrix Multi-Cloud Professional is excellent because we're dealing with multi-clouds. How do I showcase knowledge in the CV? That's something we do all the time with our students. Maybe one day I'll make a YouTube video on that. Oh, wow. Fantastic from Cameroon, from Manchester. I guess to close, if you can all type the country that you're actually in, I always love to see. I see some Cameroonians. I see some Greek people like me. I've seen lots of people that I know spread all over Africa, which I think is unbelievable, and it makes me super happy. I also see a lot of people in India. I know there's some people in Australia that have been on this call by name. So super excited. Uruguay, wow, fantastic, Carlos. We'll be back tomorrow at 9 a.m., but let us know where you're coming from because I always love to know. Kenya, fantastic. UK, India, wonderful. UK, Toronto, love this. Poland, welcome. This is great.
That's nice.
Brazil, fantastic. Alada, Greece, Spain, Delhi, more in Kenya, Cameroonian in Belgium, fantastic. Tyrone's in Cape Town, South Africa. Mario's in Bethesda, Maryland. One day I'm going to ask you where you're actually from, Mario, when we have a chance to speak. Dinesh is in Bangalore. Amaranth is in Toronto. Fantastic. This is just how wonderful to get so many wonderful people. Raleigh, North Carolina, Cameroon and UK, Mexico, Bulgaria. Wow, very fantastic. And also in Scotland. Wow, I love this. Nigeria. Thank you so much. I wish you all, happy. I wish you a happy life as well. So much. So Evo's in Bulgaria, but now Denmark. I'm loving this. Washington, Haiti. Wow. Look at that. Look at that international group. I'm actually not sure where that is. Adel, please let me where that is, because that's a country that I'm not familiar with, and I now need to know. But at least, Mario, now I know I picked up a little bit of hint of French in your accent. So, Otto, that is really cool. I'd love to know where that is. I'm going to be looking it up tonight. So thank you so much. So thank you all. Super, super happy to have you here. Let us know anything it's a state in India. Thank you so much, Umag. Thank you all so much for being here. Please come see the recruiters in the morning. Chris will send out an email. Please, please, please join us tomorrow. We're probably going to go through Saturday. I want you guys to have the best certification experience in the world, and we're doing it all for free. Thank you so much. Please like and share. If you're not a member, please subscribe. Please smack that like button and tell others to watch our training. Take care, everyone. Thank you so much.
Bye. See you later, guys.